Good morning. Good morning, everyone. Governor, Deputy Governor, and dear guests, first of all, thank you for joining us today. I am really pleased to welcome you to the 8th edition of the Central Bank of Malta Annual Research Workshop. I believe that we truly have an exciting program for you today. As usual, during this event, we will be launching the 8th edition of the Annual Research Bulletin of the Bank. To this end, Governor Scicluna will start by delivering an opening speech during which he will outline the contents of the bulletin. This year's bulletin contains 5 short articles that offer a glimpse at the research that has been ongoing during this year at the research department of the bank. In the first session of the workshop, the contributors to this year's bulletin will offer short presentations summarizing the findings of these studies. And in between these presentations, we will also have the pleasure to listen to a keynote speech by Chiara Obstat. As you might know, the theme of today's annual research workshop is the use of microdata for macroeconomic analysis. And in this light, Chiara will speak about the increased adoption of microdata for macroeconomic analysis, emphasizing the challenges and opportunities that this entails. We will also have the opportunity to listen to a presentation by Sara Spiteri, who will present her work on how to integrate granular climate data in machine learning methods in order to reveal sector and region-specific vulnerabilities to climate events. The workshop will then be concluded by a closing speech by Deputy Governor De Marco. Before starting this workshop, may I draw your attention to a few housekeeping guidelines. Kindly be informed that the event is being recorded and photos and videos of the event will be posted on the bank's channels later on. You will have the opportunity to raise questions and any comments that you might have at the end of each session or presentation. And also we will have 2 breaks, a coffee break at around 11 and a lunch break at around 12:30. So I give the floor to the Governor of the Central Bank of Malta, Professor Edward Scicluna, for his opening speech.
Good morning, distinguished guests and members of the research community. Good morning. It's a pleasure to welcome you to this year's annual research workshop and to launch the new edition of the Central Bank's Malta Research Bulletin. This publication represents the analytical foundation of the bank's policy work and the bridge between evidence and policy action. The bulletin features 5 studies. In fact, I'm going to be short because it's a very long program. These studies strengthen our evidence base across key policy areas: real-time inflation monitoring, tax design, climate spillovers, the distributional effect of monetary policy, and the development of a new macroeconomic model for Malta. Together, they enhance our capacity to interpret shocks, communicate trade-offs, and design timely and effective policy responses. The first study uses high-frequency retail price data and machine learning to nowcast inflation, improving the precision and timeliness of our inflation analysis. I'm very pleased with this study because it just shows that we are quite abreast of new developments in this field. The second examines fiscal drag in Malta's tax system, showing how indexation choices balance stability with redistribution. The third study explores how monetary policy tightening affects household wealth, revealing distinct impacts across income groups. The fourth presents a new supply-side model aligned with the ESCB frameworks and capturing Malta's long-term growth dynamics and improving our forecasting capacity. The fifth quantifies how climate events in Italy spill over to Malta through trade and prices, underlying the importance of integrating climate risks into macroeconomic analysis. Together, these contributions highlight the bank's focus on data-driven, forward-looking research that reflects the realities of a small, open economy. They also showcase the value of collaboration within the bank and with academia and partner institutions in producing relevant and rigorous analysis. I thank all contributors for their excellent work and invite you to actively engage in today's discussion. I wish the event a productive workshop. Thank you.
Thank you, Governor, for your intervention. I just wish to add that in the program pack that you can find in front of you, you can find a summary of each article of the bulletin as well as a QR code from where you can download the whole publication. Alternatively, I invite you to visit the research portal within the Central Bank of Malta website so that you can access all the research that we have published during this year. In the first session of today's program, we will be looking in a little bit more detail into the publication we are launching today. We will be presenting 4 of the 5 articles in this first session, starting with the first presentation by Massimo Giovannini, who will be presenting work on a novel database that can be used for nowcasting food inflation. In the second presentation, Glenn Abela will present results pertaining to the estimation of fiscal drag using a micro-simulation model. In the third presentation, Germano Ruizi will be presenting his work on the distributional effects of monetary policy shocks using HFCS data. And in the fourth presentation, Jacopo Zacche will present his work on the new supply-side macroeconomic model. Just for completeness, the talk on the 5th article of the bulletin will be scheduled in the later session, the last session of today's program. May I remind you that there will be a Q&A session after each presentation where you can give your feedback and comments as well as ask questions to the authors. Now I leave the floor to Massimo to start off the first session. Thank you.
Okay, good morning. Thank everybody for coming here. So today, I will be presenting a joint work with Sara and Umberto, Crumbs Make a Loaf, using product price data to nowcast food inflation. Clearly, all the standard disclaimers apply. So let me jump into motivating this work. So the food segment of HICP captures around 16% of Malta's consumption basket. And so we asked ourselves some time ago whether we could manage to track and nowcast HICP food using online prices from supermarket and smaller retailers. And now I will try to convince you that this task is not really as obvious as it can seem at the first glance. So we have a couple of challenges. Actually, we have 3 challenges. The first one is that we are trying to track official public data that are computed by NSO, but we don't know many things. So we don't know what shops NSO is monitoring. We don't know what products NSO is monitoring in their basket, and we don't know at what time during the month NSO is collecting the prices. So we are kind of working in the dark on this perspective. So on the other hand, we have a second challenge. So suppose that we have a huge amount of data, and that will be more clear later on, with the granular product level prices collected at daily frequency. And we have to transform this data set in a way that we can manage to map it to HICP categories in order to be able to nowcast the official releases. And third, there is a methodological problem because we have to find methodologies that are good in nowcasting. So once the data set is conformable and clean and everything, we need also to do actual work in order to nowcast these figures. So let me give you a preview of the contribution and the results of the work. So the two main contributions that we developed an efficient procedure to categorize products into COICOP categories using a tailored artificial intelligence-driven LLM pipeline. The second contribution is that we propose two alternative approaches. One we call it statistical approach, the other one is machine learning approach, that allows us to nowcast food inflation in Malta. Preview of the results. So the out-of-sample performance of our methodologies varies along the COICOP categories. So we are not, so some categories we perform better than others. And in general, when we compare the statistical approach to the machine learning approach, we find that in general, machine learning techniques outperform the alternative ones in nowcasting most of the food categories. So let's start to dive into the data collection problem. So what do we have? So we track 3 major retailers in Malta, 2 supermarkets chains, and 1 chain of corner shop. And the idea is that by having a mix of large supermarkets and corner shop allows us to cover 2 things. First, we cover all the main purchasing channels that households do when they actually go to shop. And second, we assume that probably the size of the shop entails different pricing strategies. So by covering both sides of the market, we also capture these different pricing strategies. As I mentioned before, we have a huge data set. So we basically collect 65,000 daily prices. And we made sure that these prices, the online prices, are match the physical ones. So we actually went to the store physically ourselves to make sure, clearly not all of the 65,000, but to make sure that the tags that we find on the website mimic the one that we could find in the actual stores. Then, okay, I will not we'll spend too much time about the data cleaning, so we tried to deal with missing data, with unreliable scraping days, because sometimes problems we have. We wanted to standardize products and website categories names in order to be able to have a good data set to do our nowcast. And also we tried to screen for label changes, because sometimes stores change the labeling, and so we try to, in order to maintain time series continuity, we had also to keep track of that problem. So let's see how the data, this is like a snippet of what you get from the web scraping. So we have products, and as you can see, there is already, you can see already one difficulty, because the labels have some Italian names, some English names, and some Maltese names. And there are alphanumeric characters, and sometimes there are abbreviations. So remember that our first task is to try to map these products into some food categories. So we need to deal with the numbers, with letters, with the special characters, and so on and so forth. Then we have the outlet, so we have supermarket B, supermarket A, and corner shop. And then sometimes supermarkets provide with some categories which not necessarily have anything to do with the categories of the official HICP or the NSO categories. So sometimes the categories can be very helpful. So if you see pasta, that can be easily mapped into an official category. Sometimes there is Christmas items, which doesn't really map into any food category that we have in mind. So this is our data set. Here, this slide basically shows one branch, which is, so from the top row to the bottom, we go towards more disaggregated categories. So there is the most aggregated one, which is a 4-digit level, which is bread and cereals. And then there are the 5-digit level, which is a disaggregation of the fourth one. And then we have been given some confidential labels at even more granular level, which is used by NSO, which clearly for confidentiality I'm not going to show. And then we have the most disaggregated part, which is the bottom, which is the products. So when it comes to the first problem, which is how to classify and how to allocate and how to find the map between items towards NSO microcategories, we need to, basically we jump from the bottom level to the third one, and so we need to have a routine that I will explain later on that matches and allocates the labels of the products into these more granular categories. Then, from the labeling problem, going from the third level to the second one, so to COICOP 5, that is deterministic, because once we manage to allocate the items to the NSO microcategories, everything else is done. Instead, when it comes to the nowcasting problem, so really how to predict prices, we have two problems because the official release is COICOP 5. So we have two steps that we have to go up. So we need first to try to, so we have to map product level, which is the bottom one, to the second one. So either we go one shot, or we can try to use some figures that we have been given at the intermediate level. And so we have a two-step optimization problem that allows us to get to the top part. So to summarize, when we go for the labeling problem, the categorization problem goes from the bottom one to the NSO microcategories. Instead, for the nowcasting, we have, for the prices, we have to go to COICOP 5. Now, let's go through the first problem, the classification problem. So the diagram on I will follow the diagram on the right. So we have our label. So I don't know, spaghetti barilla number 5. And we know from what stores it arrives. If it arrives from a store that publishes categories, their own categories, then we can try to exploit the information of the categories, and we ask our LLM model to see if, without any ambiguity, it can map the category of the shop into a category of COICOP, or the NSO microcategory. If the LLM model allows us, without any ambiguity, to map one category from the store to the category of the NSO, then all the products belonging to the store category are allocated automatically in one chunk into the NSO category. If instead, either the category is Christmas, like the one, or there is ambiguity, then we cannot play at a higher level of category, but we have to go down to the product level. And therefore, we try to exploit our LLM in trying to, so we ask with some prompts to allocate the product to the category directly. If that is ambiguous, then we try to either reiterate and ask the LLM recursively, or to allocate manually. I forgot one other step. So suppose that there is a product coming from the small corner shop that doesn't have a category, so we cannot exploit categories there, so we have the product name. At that point, before invoking LLM, we check and we do a similarity checking and check whether that product coming from the corner shop is string is similar enough to some other products that have been already allocated to the correct category from the NSO. If that happens, then we don't need to use LLM anymore, but we can trust the similarity of the label and automatically allocate that product to the appropriate category that we will use for nowcasting. So, how to, then the problem is, okay, that's very nice, very fancy stuff, but we need to check whether our algorithm makes sense or not. So what did we do? We had to do some human benchmarking. So we asked people, our colleagues, we took a sample from our big data set, and we gave to humans, and we asked to perform the same task given their own knowledge. And therefore, the game here is, in order to validate our routine, is to see whether, what is the degree of alignment between what our procedure allocated, how the procedure allocated products to category, and how a human being will do that. And we see from the bottom table that in the more disaggregated level, the accordance between humans and our routine was 79%. But as we go to more aggregate level, the alignment between what humans, the allocation of humans and the allocation of our procedure goes to 95%, meaning that 95% of the products were allocated to the same category by humans and our routine. We also have to notice that at more disaggregated level, also humans displayed some disagreement, because not always is obvious that a product can be easily mapped, even given our knowledge, to a well-defined category, because if categories are disaggregated enough, there could be some proximity, and you are also a little bit ambiguous about where should I put this product or not. So it means that ambiguity that we get from our routine is not because necessarily the routine was weak, but because inherently the problem is difficult, also for a human being. So once we have allocated our products to the correct category, once we're happy about the allocation, then in order to perform our nowcasting, we need to create our panel. So the idea there is that since we don't have a big time sample, we needed to, we could not afford to have categories with many, many products, because that would kill all the degrees of freedom for our problem. So when we had categories very rich, in which the numerosity of products were large, we said, okay, we want to prioritize, and so we just keep the most popular products. What does it mean? And so for us, popularity means that the product is sold in more than one store. So that is one selection that we did. And we think that clearly also the statistical office probably tracks popular products, which most likely are present in more stores. And this, of course, in order to match, since not the labels of the same product in different stores is the same, we have to develop also an algorithm to match identical products across outlets. But on the other hand, sometimes we had categories which were very sparse, with few items, and in that case, we relaxed our hypothesis of extending to popular products, and we also tried to keep in and bring in products that were only present in one store. At the end of the day, the panel that we use for our nowcasting is constituted by 5,000 products, and the distribution between the different outlets is the one that you can see. So the corner shop is 13%, and the two other supermarkets, 33 and 54%. So let's jump now into the actual nowcasting exercise. So here, like, I want to put a little bit the struggles that we have. So what we don't know. So we don't know the products that NSO tracks. We don't know the stores. We don't know the time. And also probably we know that we are playing a different game from the one that NSO plays. Why? Because we started with 65,000 products, and we believe that probably NSO is not tracking as many products as we have. So we have an advantage in the sense that we have our cross-section of products is much larger than the one the statistical agency have. But on the other hand, we are only tracking 3 outlets, and most likely NSO is tracking many more retailers than we do. So we are kind of basically mapping a problem. So our target, which is, say, NSO, has a large number, a large cross-section of retailers and a small cross-section of products. Instead, we have the other one. So we kind of proxying our, so we try to leverage on our richness on products in order to fill the gap on our weakness, which is the size of retailers. Then, of course, we don't know what are the weights that NSO gives to products, and we don't know what are the weights that map the micro-categories of NSO to COICOP 5, and we don't know when NSO conducts the sampling. So here we propose 2 alternative approaches. One we call statistical, and the other one the machine learning approach. And basically here in this slide, I would try to answer those questions of the previous slide, and how we try to answer those questions with 2 different approaches. So the statistical approach mimics what NSO does. Instead, the machine learning approach is purely data-driven. So why I say that the statistical approach mimics what NSO does? Because it proceeds at 2 steps. And now if you remember the slide, the blue slide that I put up 8 minutes ago, I told you that for the nowcasting, there are 2 steps. We have to go from the products to NSO categories to COICOP5. So what we do with the statistical approach, we try to optimize, we do a constrained optimization that minimizes the distance of the weighted average of product prices to the official release in 2 steps. So first with the figures at NSO microcategory level, and then from the microcategory level to COICOP5. So, and the constraints are that the weights cannot be negative, and they have to sum to 1. So in order to have a really more interpretable understanding of what the index is. Words of caution. We are not after inference. So since we play a different game, so we have many more products, less stores, we don't want to estimate and make inference about which products are tracked by NSO and what are the weights that NSO does. That's not what we want to do. We want to find, compatible with our data set, weights that allow us to track the public available information. The machine learning approach instead doesn't go even through the NSO microcategories, jumps directly and try to make a prediction using different models, MIDAS, OMIDAS, LASSO, and so on and so forth, to really map the granular data directly to COICOP5 level. And then there is also another, you remember that there is a problem that we don't know when NSO collects the data. So we have also in there 2 different responses, because the statistical approach takes daily data and computes monthly averages, whereas the machine learning approach is much more flexible and aggregates it weekly and allows flexible weighting across the weeks. So let's confess ourselves, what is the weakness of our approach so far? The problem is that we have few data. So we started collecting this data in February 24. So our sample for this presentation and also for the Research Bulletin article goes from February 24 to June 25. And the training goes from February 24 to April 25. And we have 2 months, May and June 25, that are used to test the nowcasting. So we know and we are well aware that the data points are few. So that's why this is a preview. Is like an ongoing project which will probably converge to some stable solutions in the next couple of years. So we have, together with the 2 approaches, that the statistical and the machine learning approach, we also try to do a naive model, which is just products mean. We don't take any weights, we don't do optimization, we do nothing. We just take all the data, we take averages, and we see whether averages are enough to perform well in nowcasting the NSO HICP food. And all the, as I already mentioned, so the results that I'll show you in the next slides will be at COICOP4. Even all our routines predict COICOP5 because, as I said, the weights that map COICOP5 digit to COICOP4 are deterministic. We know, they are official. We know what are the weights that put 5-digit level prices to 4-digit level. And the figures that I'll show you will be relative to the prediction, monthly prediction done by our colleagues during the NIP, so the Narrow Inflation Project exercise, which is also done at granular level, at the same COICOP4 level, and practically uses ARIMA models. So, preliminary results. So on the table on the right, you will see 3 columns. So the first column is the naive model with the products averages. The second one is the statistical approach. And the third one is the machine learning. And you will see some stars and some red numbers. So what is a star? If you see a star, since these are root mean square error relative to the root mean square error of the NIP, if a number is less than 1, it means that that model for that food category outperforms NIP. So when there is a star, it means that that model for that category does better than NIP. What are red numbers? For each product category, I put in red the best model. As you can see unambiguously, the third column, the machine learning, has more stars and more red numbers, meaning that with few exceptions, and I want to point your attention to vegetables, where you see that 13.48, because I'll come on that in a minute, which is a huge number. But aside from that, basically the machine learning technique is outperforming NIP and outperforming alternative models. Now, let's go back to the 1348. Vegetables are, let's see if I can, okay, are here, okay? It's very difficult, okay. So, let's look there. You see the blue line, that is the machine learning. The vertical line is the end of the training. So, on the right of the vertical line is the forecast or nowcast. As you can see, before the vertical line for vegetables, the blue line was almost on top of the dark, which is the actual data. But then, as we move to the right, completely jumps. That's a case of overfitting. It means that the machine learning process was not optimized with hyperparameters and everything. And so for that category, it was putting lots of information that was useful for in-sample fit, but were not useful for out-of-sample. On the other opposite, if you look at fruit, which is the third column, second row, there, again, machine learning was tracking the actual figures, but also out-of-sample, that didn't cause a problem of overfitting. So this is a caveat, so sometimes, and this is why we need more data to train our model better in order to avoid this type of problems. To conclude, so what we've done so far? So we sampled many products with an automatic scraper from 3 different outlets. And we developed an artificial intelligence pipeline that allows efficiently to allocate labels of products to categories. And second, we created a panel that has the same criteria that HACCP does, so that we can use it for this type of nowcasting. And then we developed 2 alternative approaches, the statistical and the machine learning approach, to perform nowcasting. And these 2 approaches, inherently, they have a sort of a trade-off, because the statistical approach, since it mimics what NSO does, has more interpretability because the weights have some properties of being non-negative to be summing to 1, whereas the nowcasting is a pure data-driven that performs better out of sample. So I think that this is all I had to say. If there are questions, I'll be very happy to take any question that you might have. Please. Maybe you can use the microphone.
Thank you for the paper. Thank you to the co-authors. Just one remark. If you were to, I saw that the worst performance, in a sense, relative performance, was fruit and vegetables. No? These would go into the unprocessed food category. So if you were to take processed food items versus unprocessed food items, presumably you have a very good performance, relative performance for processed food.
Yes.
Which would then suggest to me that you have a routine that can be used in the NIP instead of what we currently do, you know? Because
so if you look at the last column, and if we trust just 2 data points, because the sample is small, with exception of milk, cheese, and eggs, and vegetables, all the other products have a star, meaning that they are on the samples that we use, outperforms NIP in terms of RMSE.
will you be extending the exercise over time? So that we
Yeah, of course. So this is like a preliminary, because we need a couple of years of data more in order to train the model better and to understand the pros and cons of the alternative approaches. But I thought that was useful, since it's the first time that in Malta we are doing something like that, to give a preview of the results and the approach, and to see whether also the feedback from the research community was how it was.
Okay. Thank you, Massimo. Looks nice.
Just one point on this one. Actually, I find very reassuring that in reality the only category in which you are not outperforming are vegetables, fruit, and milk, cheese, and eggs, because I think that are like the ones where it's much more convenient here in Malta to buy locally, because the other one are imported. So like you always would see that if you buy local, it's much cheaper than going to Lidl, Greens, etc. So in reality, it's very well reassuring. One question that I wanted to ask you was, after the spike in inflation in 2022-2023, there was a lot of discussion about if prices would ever go down, and a lot of people were arguing we wouldn't expect prices going down, but rather more offers.
Mm-hmm.
And so I wanted to ask you whether you managed to capture also, for instance, if there was like offer minus 20%, would you be able to capture with this?
Yes, so we keep track of offers, not only if there is the word offer, but also by looking at the behavior of the prices. So if the price drops and stay down for a certain amount of time and then goes back to the same level, then even if it is not detectable directly that was an offer, we interpret it as an offer. And in fact, okay, these are going, because from this data set, as you can know, that can be many, many projects that we want to do. So we are also looking at different pricing strategies. We saw that different outlets, sometimes some outlets play more with prices, some others, they play with offers, sometimes they play with changing the composition of the products. So the data set is very rich. Here, I wanted just to focus on what we did for this particular exercise, but many others are in the pipeline of our team in order to answer different questions. Okay, thank you very much. So I'll give the floor to the next speaker, Glenn Abela. The floor is yours.
So, thank you, Massimo, and good morning, everyone. Today, I'll be speaking about some joint work with Ian De Battista about fiscal drag in Malta's personal income tax system over the period 2017 to 2025. And as usual, the normal disclaimer applies. The views expressed here are attributable to us and not necessarily to the central bank. So, when we think about how taxation, how inflation affects households, we might not always consider the channel of fiscal drag, which basically arises when, under a progressive tax system, growth in nominal income possibly leads to higher real tax burdens if the parameters of this tax system are not indexed sufficiently to inflation. Now, in personal income tax systems, or PIT systems for short, we normally find two kinds of parameters that are subject to indexation. The first are the thresholds that separate different rate bands in a progressive tax schedule, and the second are the values of tax deductions or benefits that are included in the system. And in turn, these two types of parameters correspond directly to the two main channels through which fiscal drag operates. So the first is, and maybe the most prominent, is bracket creep, where growth in nominal income pushes taxpayers into higher marginal rate bands if the thresholds that separate these rate bands are not indexed sufficiently. And the second is benefit erosion, which basically describes the process through which the value of tax brackets and deductions is eroded over time if it is not sufficiently updated with inflation. Now, fiscal drag is perhaps particularly salient under high inflation because you might have the situation where households face higher real tax burdens whilst not experiencing any growth at all in their real income. But even under low and stable inflation, fiscal drag can compound over time, especially in systems where indexation of tax parameters is not automatic. And given this context and also recent developments in Malta's income tax system, we believe that Malta provides quite an interesting case study in this regard. So, like many other European countries, first of all, Malta's income tax system does not feature any statutory indexation. And during the period between 2016 and 2024, tax bracket thresholds were kept unchanged before a substantial adjustment was implemented at the beginning of this year. However, in the intervening period, there were, first of all, a number of discretionary changes to pre-existing benefit parameters, as well as the introduction of some new rebates and benefits. And therefore, our study sets out with the following two goals. First, we want to estimate the buildup of fiscal drag in Malta's income tax system since 2016, which is when the tax bracket thresholds were last indexed prior to this year. And second, we want to quantify how much the measures actually implemented during this period serve to compensate for the lack of regular indexation. To do this, we follow the methodology of Garcia Miralles and co-authors. We employ a tax benefit microsimulation model, specifically Euromod, which is a microsimulation model for EU countries, to simulate income tax liabilities at the individual and household level using representative microdata. And in turn, the use of representative microdata allows us not only to analyze results at a very granular household level, but also to derive meaningful aggregate changes when simulating different policy scenarios. Now, a word about microsimulation models. First of all, these models inherently allow you to isolate the effects of the changes, of the policy changes that you are simulating by keeping all other factors constant. However, when it comes to microsimulation models like Euromod, which are static and non-behavioral, we have to keep in mind that any results do not reflect any, for example, multiplier or second round effects that might follow from the policy changes that are being simulated, and also do not take into account any potential behavioral changes by economic agents. So these models will give you purely the pure arithmetic effect of applying a different tax system to a given level of taxable income. In terms of the microdata, we use microdata from the 2023 edition of the EU Survey on Income and Living Conditions. In this edition, the reference period of income is the year 2022, and as a standard in the microsimulation literature, we apply appropriate indices to adjust the levels of income in the data set so that they accurately reflect the income levels actually observed in each simulation year. Now, our study hinges basically on the simulation of 3 core scenarios for each year between 2017 and 2025. The first 2 of these 3 core scenarios are sort of benchmark polar cases, which are both based on the tax system as it was in place in 2016 before, which is basically when, as I said, tax brackets were last indexed prior to this year. So the first of these 2 is the no indexation scenario, where basically here we apply to the taxable income in each simulated year T, the tax system fully as it was, completely unchanged from the year 2016. On the other end, we apply the full indexation scenario, where we leave the structure of the tax system as it was in 2016, but we apply full indexation to the monetary parameters up to year T using 1-year lagged HICP inflation. And the difference between the tax liabilities that arise under these 2 polar cases, where, of course, the tax liabilities under no indexation will be higher than those under full indexation, we label as potential fiscal drag, or basically, you can think of this as the maximum possible buildup of fiscal drag between 2016 and the simulation year T. And we use this potential fiscal drag as a benchmark against which to compare the tax liabilities that arise under the actual tax system, which is the 3rd core scenario that we simulate in each year. Then, the difference in tax liabilities between the actual scenario and no indexation give us the share of this potential fiscal drag that has been compensated by the measures actually implemented between 2016 and year T. Any remaining difference between tax liabilities under the actual scenario and full indexation reflects fiscal drag that actually materializes in our tax system in that year. Obviously, it might be the case that the actually implemented tax system is more generous to taxpayers, so to speak, than full indexation since 2016, in that case, we'll have the situation where realized fiscal drag basically turns negative. In one last step, then, we use an intermediate scenario to decompose offset fiscal drag into the part offset by reform measures and the part offset by indexation. Now, when I refer to indexation here, we are referring, again, always to adjustments of monetary parameters, and any other changes are basically labeled as reforms. And the table on this slide basically shows all the changes implemented to the tax system since 2016 that are included in our scenarios and grouped in our simulations and grouped under each of these two headings. Now, I don't have time to go through all of them, obviously, but it's good to point out that apart from the tax cut or adjustment to the tax brackets that was made at the beginning of this year, which is accordingly listed here as an indexation measure, the two most important measures to note are perhaps two reforms that affected tax liability on pensions. First, we had a rebate in 2017 where up to a maximum amount, tax on pension income would be reduced from the tax liability of the pensioner or rebated to the pensioner. Then in 2022, we saw the start of a gradual process that will conclude next year, whereby all pension income is fully excluded, again, up to a maximum amount from the tax base. So, turning to our results, we start from looking at aggregate tax revenues, which obviously give us a sort of high-level view of how households were collectively affected by fiscal drag in each of the years simulated. So on this chart, we are showing the share of potential fiscal drag that is offset by reforms and indexation measures. On the left-hand side axis, potential fiscal drag is normalized to 100%, shown by the black line. And on the right-hand side axis, it is shown in absolute values in millions of euros. Now, the teal bars show the share of potential fiscal drag offset by reforms between 2016 and that year T, and the red bars show the share of potential fiscal drag offset by measures classified as discretionary indexation. If these two bars fall short of the black line, that means that some fiscal drag would have materialized in that specific year. If, on the other hand, these two bars more than exceed the 100% line, that means that some fiscal drag has been overcompensated in that particular year. And in fact, in the first 2 years that we look at, we basically find a situation where the low potential fiscal drag that had built up in the system since 2016 had been more than offset by government measures. And once again, we attribute this to the pension tax rebate implemented in 2017, which I just spoke about, as well as a significant increase in its maximum amount, which was implemented in the year 2018. And then we see that the first onset of fiscal drag in our income tax system occurred in the year 2019. So even though, of course, previously implemented reforms and some other reforms were still in place, and we also notice a growing role of discretionary indexation measures, these were still not enough to completely offset potential fiscal drag when comparing against full indexation since 2016. And if we want to quantify it in monetary terms, we see that, for example, in 2019, tax revenues we estimate were around 4 million euro higher than they would have been under full indexation, which basically stays at quite stable and low levels and ends up at around 8 million euro by 2021. Then some things change a bit more rapidly in the following period between 2022 and 2024. So as we all know, this was a period that was, first of all, characterized by a significant increase in inflation. But first of all, in 2022, again, as I mentioned, we saw the start of this phased-in exemption of pension income, which served to, at least temporarily, increase the share of potential fiscal drag that was compensated by reform measures. However, then in 23 and 2024, we see a spike in potential fiscal drag due to the high lagged inflation effects owing from the basically increase in inflation that materialized in the preceding years. In fact, we see, again, we estimate that when comparing to full indexation since 2016, actual tax liabilities were around 54 million euro higher in 2023 and 107 million euro higher in 2024. However, then we come to the tax system in place this year, and we estimate that the system in place this year will actually reverse the increasing trend in fiscal drag that we have observed during the preceding years. So again, both due to the contribution of previously implemented reforms, but also given a significant contribution from the tax cut implemented at the beginning of this year, we actually estimate that tax liabilities this year will be around 41 million euro below what they would have been under full indexation. And this also serves to suggest, to underline really the strong impact that indexation of tax brackets has in terms of the extent of tax liabilities in Malta's income tax system. Obviously, the finding for this year does not mean actually, that the fiscal drag accumulated in previous years is wiped out. In fact, if we sum excess revenue due to fiscal drag over the whole period of analysis, we find that taxpayers would have paid around 145 million euro more due to fiscal drag than they would otherwise have under full indexation, keeping everything else constant. However, it does mean that at least the tax system in place this year is more generous to taxpayers, so to speak, than full indexation since 2016. Now, we have seen the fact that, or we have concluded that it's been more generous than full indexation based on aggregate tax revenue so far. But since, obviously, aggregate tax revenues will be somewhat dominated, or, higher earning households will have a higher weight in the generation of aggregate tax revenues, we might want to see if this finding extends all across the income distribution. And in fact, if we plot the share of potential fiscal drag offset under this year's tax system by deciles of household taxable income, we find that it is essentially the case that this year's tax system more than offsets potential fiscal drag across all the distributions except for the top decile. In terms of what's driving this, of course, we see that the tax cut implemented this year is pretty dominant across all the income distribution, but especially in the bottom half of the distribution, we also see a strong contribution from reforms. Once again, we attribute most of this due to the strong measures that were implemented to alleviate tax, especially for pensioners. And if we focus slightly on the case of the top decile, we attribute the result that we notice for the top decile to two factors. First of all, of course, in relative terms, benefits that reduce tax liabilities for taxpayers in general will be relatively less prominent for this decile, but also we notice that the tax cut also offsets a relatively smaller share of fiscal drag for this decile. And we attribute this to the fact that the threshold that basically separates or denotes the highest tax rate bands, which obviously households in this decile are more likely to fall under, and which has been unchanged at 60,000 euro since 2016, basically was not adjusted at the beginning of this year. And for comparison, under full indexation since 2016, this highest threshold would have been approximately around 74,000 euro today. Lastly, we turn to the effect of fiscal drag and the measures that might have offset parts of it on the redistributive capacity of the tax system. So in the microsimulation literature, a summary metric that we often use to measure the redistributive capacity of the tax system is the size of the reduction in the Gini coefficient that it implies compared to the Gini coefficient on the pre-tax income distribution. Now, in this chart, we are plotting the percentage reduction in Gini coefficient under each scenario in each year. And obviously, therefore, a higher line signifies that that specific tax system is having a higher impact in terms of reduction of income inequality. And if we focus a bit, especially on the teal line, which denotes the tax system actually in place, and the red line, which shows the full indexation tax system, we see that throughout the whole period, the tax system in place actually delivered stronger inequality reduction than full indexation, even if it also implied higher tax liabilities on aggregate. And this is mainly driven by policy reforms, which we show by also plotting in the chart our intermediate scenario, which is labeled actual excluding indexation. So basically, the fact that the gap between the intermediate scenario and the actual scenario is very small all across the period basically shows that the role played by indexation in creating that gap compared to full indexation is quite small, and and therefore the increased income inequality reduction under our tax system was mainly driven by the progressive reforms implemented throughout the period of analysis. To conclude, I'd like to briefly recap our key findings. So first, we see that since 2016, some fiscal drag has accumulated in Malta's income tax system. In fact, we see that it started to materialize from 2019 onwards and accelerated somewhat in the high inflation years of 2022 onwards, where it peaked at around 107 million euro in 2024, until the tax system in place this year, also boosted by the tax cut implemented at the beginning of the year, is expected to actually overcompensate fiscal drag by around 41 million euro. Over the whole period, we estimate that households paid around 145 million euro more in taxes due to fiscal drag, obviously keeping everything else equal, but at the same time, the system in place was more redistributive than the fully indexed system, than a fully indexed system since 2016 would have been. And therefore, to offer a concluding thought, maybe our results seem to hint at a bit of a policy trade-off. So clearly, automatic indexation would prevent build-up of fiscal drag in a tax system and would perhaps offer more predictability. But it would also limit the discretionary ability of government to use the income tax system as a policy tool. And moreover, as our results also suggest, discretionary indexation can also be used to achieve targeted distributional gains, whilst also allowing some flexibility to government to, for example, accumulate some fiscal space and for use when necessary, which might also, after all, be used for other redistributive measures outside the framework of the income tax system. So, on balance, basically, there is no clear-cut choice between automatic indexation and discretionary indexation, and fiscal drag is not inherently itself good or bad. What matters for how it affects households will be how government manages it and basically amalgamates it into its broader policy stance, and also how the revenue it generates is used by government in its fiscal policy measures. That's all from my end. If you have any questions, please go. Yes?
Yes, I find the paper very interesting, especially having lived it for 8 years. I would like you did at the end, it was a very good ending, is to look at the political economy of it. I mean, from the economic we know, it's a taxation by stealth. And so long that unions and the people would accept it, you know, you will carry on pushing it. Imagine tomorrow, Glenn, you'll be appointed finance minister. And what you'll find is the EU breathing down your neck to reduce your deficit, okay? And you'll find it difficult on the expenditure side because there is an enormous sense of entitlement, from the Minister of Finance that every budget is like Christmas and you just distribute and you need to have something in your bag to distribute. And no matter what you do, it's not enough, okay? So that's one push. Then the other promise, which your previous predecessor did say, and it's being accepted, that you can do anything but taxation. Taxation is the dirty word. Of course, no one wants to accept it, so you don't touch that either. And then as an economist, you have wage indexation. Luckily, we have a partial one, with the COLA, cost of living adjustment, which is, not really a full wage indexation. And so you have all these pressures from each side. And then you have left this hidden taxation. That's what it is. And you're the last bastion before you give it up, But as you said, you're not, that gives you fiscal space. That's what it is. Now, depending on how you use it. You want to be seen as, again, like the Father Christmas, that it's you with your benevolent attitude, you're going to give something, a tax cut, or this, but not automatic, because then you don't get anything in return politically. So it will be, it will take years. I mean, there are countries where they have full indexation. It's fair, it's fair. But keep in mind also that another principle was introduced of this tax refund. Now, many people joke about it because they get a check. The US is apparently copying it too, where they send a check at home. We call it a tax refund. But strictly speaking, that was the beginning, unfortunately hasn't developed since then, of a negative income tax. In other words, the principle that you don't stop with progressiveness from whoever is earning income, but also those below the tax pressure should have also progressiveness by having a negative income tax. In Canada, there's something scheme where students, for example, get a refund even though they don't pay tax, and so on. So, looking at the political economy, I agree with your conclusion that it gives fiscal space, depends on how it's used. We hope that it's used well, and depends on its politics, depending on what pressure, whether you can keep hiding this, or not.
So thank you for that insightful comment. And in fact, yes, it's maybe something I didn't have time to go into, but even from some joint work we've done also with colleagues from other central banks about this topic, we see that in fact, over the recent period, fiscal drag has arisen in more than half of euro area countries, if you consider all that period. And automatic indexation, in fact, is not all that common, even across the euro area. Any other questions? Yes.
One or a comment. You said very, very clearly and correctly at the beginning that this is not a behavioral, so it abstracts or anything behavioral. But this prevalence of the kind of reduction of the fiscal drags on the pensioners basically prevents one effect of the undoing the fiscal drag on the labor supply, right? Because this is the part of the population whose labor supply basically is very inelastic. I mean, some may go back to work if they're overtaxed, but not really. So is that a kind of a general equilibrium consideration that by getting this fiscal space, you are, say, by using this for fiscal space, you are kind of limiting the labor supply? And is this a problem in Malta specifically? I confess my ignorance about the labor market in Malta. But this will come more and more important as working age population shrinks, and then the incentives to make people work who are not working is growingly important.
So your question is sort of that by offsetting fiscal drag on pensioners, you will still not be having much effect on the labor supply. Well, I think that part of it is really a bit of a social measure as well. Yes, it is true, but part of it then will come also from the social aspect. Of course, as you correctly said, through this model we cannot model this, we cannot capture it, but it's actually a good point to also maybe think about more in the future as well, when it comes to maybe publishing this work.
Glenn, if I might add something on this, but there have been other measures that were targeted at reducing this effect, like working benefits, that reduce this kind of fiscal drag that, as you rightly said, could impact labor supply. But there were other separate measures which were not part of this study that kind of tackle it. Now, whether they tackle it completely, we don't still know. But
Okay, so that's everything. Thank you again, and I leave the floor to my colleague Germano for his presentation. Thank you.
Hello. Okay. Bonjour, good morning, everyone. So, okay, the slides are there. So this is a joint work with Valentina Antonaroli, which is here on the first row from the macroeconomic data analysis office. And, well, the title is quite self-explanatory. So we're going to look at the monetary policy, and then we'll try to see what are the implications at the household level. But let me go step by step. So first of all, obviously, these are just our views. And let me motivate. Obviously, recently, after the recent monetary policy cycle, with a tightening in response of inflationary pressures after COVID, there was a renewed interest in, obviously, monetary policy. Not only, obviously, around the world across major central banks, but also here locally in Malta. In the specific case of Malta, we want to look at the household sectors, because when we look at the households, from the asset point of view, we see that in Malta we have a high home ownership rate, with around 80% of the households owning the property they live in. While when we look at the liability side, we see that most of the indebtedness of these households is mostly for mortgage debt. And if I do remember correctly the data, around 70–75% of the mortgage debts are characterized by they are interest rate adjustable interest rates, so they are susceptible to changes in interest rates. What we do in this work, just to give you a preview, we essentially do two things. We try to understand the effectiveness of monetary policies in Malta from an aggregate perspective, so from a macro perspective. And we do this by using a structural vector regression approach. And then in a second step, we try to understand what this means for households. And we do this by mapping macro responses with microdata that we obtain from the Household Finance and Consumption Survey. So with this microdata that we have available for households in Malta. The wave that we use is 2023. Main findings, again, a preview. We do find heterogeneous effects across households. That depends on their wealth level and wealth, obviously, composition. Unexpectedly, in our case in Malta, locally, housing seems to be the main transmission channel. And then we're going to see this in the remaining part of this presentation. So in the remaining part of the presentation, I will follow these two steps highlighted in the contribution. First, I will discuss the macro part of this work, the macro approach, and then we see what this means from a micro perspective. So aggregate fluctuations. So we try to find macro implications for Malta, given a tightening in monetary policy. And we use, now here at the bank, use quite often, two-block VAR, in which we model together the euro area as a whole and Malta. We do this together. The characteristic of this approach is that we know that Malta is so small that cannot influence the fluctuations of the euro area as a whole, but on the other hand, the euro area as a whole does influence the fluctuations of Malta. That's the characteristic of this model. Obviously, this equation is just a very simplified version of the model. There is much more, and then in case somebody is really, really curious about the details, at some point we'll publish this as a working paper in which we go through each of the two blocks, the euro area and the Maltese block. But just to give you a flavor of what there is inside the model, for the euro area, we use the growth rates of real GDP, HSEP inflation, the one-year bond yield, the Euro Stoxx 50 index, and the composite indicator of systemic stress in the euro area. Identification is performed in the euro area block, obviously. It's done in the spirit of Jaronczynski and Karadi, 2020, which uses the monetary policy surprises collected in Altavilla et al. 2019. So essentially, we do apply some restrictions on the high-frequency responses of essentially these two financial instruments, the 3-month IS and the Euro Stoxx index. So within the 30-minute window of the policy announcement, we assume that a monetary policy shock increases the 3-month IS and decreases the Euro Stoxx 50 index. In the case of Malta, we do use the business conditions index developed by Ruben and Lull, which is here in the audience somewhere. We use core HICP inflation, and then we use the 10-year sovereign spread over the German Bund. The Maltese block is a little bit more complex, and in fact it contains also a factor structure that aims at summarizing the information contained in a large panel of data for Malta that are meant to essentially capture the main variables of interest when studying the transmission of monetary policies. So essentially this factor structure aims at capturing a number of yields on Maltese government bonds, a number of banking retail interest rates, asset prices, labor market indicators, and other inflation measures that go beyond the core HICP in inflation. When we apply this model and we shock the model with a tightening, we do find these impulsive responses. So in red, we find the responses for the Maltese economy. In teal color, we have the responses of the euro area as a whole. Unexpectedly, we do find a slowdown in economic activity, both in Malta and in the euro area. Maybe I didn't mention, the BCI for Malta is a measure of business cycle, business conditions. So a decline in the BCI is a slowdown in economic activity, for those who might not be familiar with this indicator. We also do find a slowdown in inflation, and an increase, please allow me to use the term in riskiness, both in the euro area and in Malta, as expressed by the increase in the composite indicator of systemic stress and the sovereign spread here locally in Malta. No surprises for the stock market index that experiences a downward pressure and then increase in the one-year bond yield. So this was just the first layer of the responses. Then, when we try to see what happens locally, still from a macro perspective, we do find some interesting IRFs. Obviously, as I said, the model is meant to, the factor structure in the Maltese block is meant to summarize a large number of variables. This is just a number of them, which are, I believe, interesting for this presentation. We do find an increase in the bond yield, the 10-year bond yield, the Maltese one. We do find some responsiveness also of retail banking interest rates. Interest rates on loans for households appear to be slightly more responsive than those on deposits, both current and saving deposits. We do find a slowdown in equity prices as prices, operating surplus is a measure of profitability of businesses, a decline, slowdown in HICP vehicles, and then we do find a an increase in the value of in the inflation relative to jewelry and clocks, we do interpret this as a possible shift in preferences of people that in a period with a negative outlook of the economy, they might be willing in investing, putting their money into more safe assets. That's the way we interpret this. So these are the responses from a macro perspective. And this enables us to go to the second step. So we try to see what this means for households across the wealth distribution. So what we do, we try to devise a mapping scheme that goes from macro responses to wealth components of households. I'm not going through the whole table, but it's there just for you to understand that, for example, if we look at real assets, we try to map the value of properties of households with the responses of house prices. For example, for financial assets, we try to map the value of deposits with the responses of interest rates, retail interest rates on savings or sight deposits. From the liability point of view, the response of the interest rate on mortgages, essentially, can be useful to us to understand how the outstanding values of the debt, or mortgage debt, might change in response to monetary policies. Obviously, given that we know that more than 70% of the loans locally are interest rate adjustable. So we apply this mapping scheme to households which are divided into deciles, wealth deciles. We select just 4 of them in the interest of space and interest of time, and we compute these asset-weighted responses. So the deciles we select are the first, second, fifth middle decile, and the 10th decile. The very first thing that we can notice essentially is that if we go up the wealth distribution, households that are wealthier tend to have essentially to be characterized by a bigger response of their assets. If you look at the fifth wealth decile, so the middle decile, we do find that the response is mostly due to fluctuations in the value of their properties. If you look at the 10th decile, in terms of magnitude, is roughly similar to the fifth, but it's highlighted here how this response is characterized by a more diversified portfolio. So we do also find not only the main residence, fluctuations in the main residence, but also fluctuations in the value of other properties, as well as fluctuations in the possible value, in the value of the self-employment business, which is something that characterizes more wealthier households. If we instead we look at the top 2 graphs, the first and the second decile, we do find that these households or households that are in these deciles are the ones that are hit the least, mostly because the portfolio does not really contain much housing, especially the first decile. Most of the decline, the fluctuations, are due to fluctuations in their vehicles, the value of their vehicles. So they are very not really hit. So if this is the response from the asset side, the liability side essentially is this one. Again, the first decile doesn't seem to be hit. The households in the first decile do not really have probably the opportunity to have access to a mortgage loan, so they don't really experience the pinch of a higher outstanding debt in response to higher interest rates. Instead, the others do experience. The mostly hit are again the fifth decile, and then in the 10th decile, we can still see that there is an increase in the value of their debt. But again, now here we can see that also this debt is also due to finance the purchase of other properties besides the main residence. So we can see the compositional effect of this increase in the value. So essentially, these are the main findings of this paper. So it depends on the wealth level and the wealth composition. So in conclusion, essentially, just to summarize what we do in this work, we try to tackle the topic of monetary policy shocks in Malta. We try to find an answer from a macro perspective and then also from a micro perspective. We uncovered the transmissions to the whole economy. Not surprising, we do find a slowdown in economic activity in prices and increase in riskiness. We do find convincing responses from the point of view of asset prices. Instead of the micro level, the household level, we do find heterogeneous effects across wealth distribution that depends on the level of wealth as well as the composition. For poorest households, we do find that they are the least affected. They have limited asset ownership and very low levels of indebtedness, so they don't really feel the pinch. From the point of view of the middle deciles, they appear to be the most hit. The housing, their properties experiences a slowdown in prices, while on the liability side, they are particularly affected by an increase in interest rates. Instead, the wealthier, they do have a more diversified portfolio, but they have at the same time a lower level of indebtedness, so the response, the overall response from the wealth point of view, when we sum up the two sides of the coin, the overall response is a little bit milder with respect to the middle deciles. So this is pretty much my presentation, and I thank you very much for your attention, and I'm very happy to take questions, suggestions. Obviously, we are still working on this project, so any comments, suggestions are very much welcome.
I didn't understand whether whether the analysis takes the asset side and the liability side separately.
Yes.
Whether you try to take the net position across income. Well, it makes it probably a difference.
At the moment, just for easiness of explanation, that's what we do. We separate the two to make it easier, so you understand the assets and then the liabilities. Actually, what we do in this work, and then this will be shown better in the paper, we take the compounding effect between the two, and we do find more precise results. But again, it will be heavily influenced by the asset side. So what you see from the assets is mostly what you will see when you put the two things together. But that's correct, that's correct. We do have results that will be in the paper. Maybe I'm going to give some results. Again, in that paper, we'll see that essentially, again, the middle deciles, they will experience the biggest loss or the biggest decline, the biggest slowdown in their wealth. But that's correct.
About the monetary policy transmission mechanism, what does this imply? And on your assumptions, how it translates the monetary policy to interest rates in Malta?
What do you exactly mean? So essentially, at the moment, what we speak?
Because as
you
you know,
we are referring to the recent past, essentially.
Mm-hmm.
Okay, so the model has been estimated with a sample that goes back to 2002, essentially. So what you see here is an average response across the sample. Obviously, we are not, with this model, we don't capture the very recent past. That can be done with a different kind of model, maybe with a time varying parameter VR model, that can be done. So you can trace what happened in the past and what's different with respect to now. This model is a time invariant, if we want to use the exact definition. So what you see is an average response. But obviously your point is valid. If we really want to see what happened recently, we should go time varying. At the bank, we do have some models. I did it in the past, and it can be applied. But it can be another step. But thank you for this point. Because obviously what you're referring is to the fact that recently, given the monetary tightening here in Malta, we didn't really see any spike in retail banking interest rates. I'm aware of that. And that's why I'm saying that we can tackle this issue from a different modeling perspective. So I don't have the answer now, but please take these results as an average response across the sample. But still, I believe that we can already see the low responsiveness of retail interest rates if we look at the response of deposit rates and also mortgage rates.
Thank you, Germano. Besides the interest rates, impact of a monetary policy tightening? Have you considered the exchange rate channel?
Not really, but that can be interesting. Yes, thank you, John. Thank you. I mean, from an econometric perspective, we can enlarge this model as much as we want. We can put more variables because the factor structure, especially in the Maltese block, allows us essentially to put in there many variables. And luckily, the more the information, the better it is. So thank you. We can also consider that. Thank you. Okay, one more question.
Just, is it possible to compare the impact on wealth of the different households of Malta and the euro area with this model? I think that would be possible.
With exactly this model, maybe no. You can change it. You have to do some changes, probably in the euro area block. You can, definitely, you can. If you play around with econometrics, you can do that. With this one, exactly this one, like click and play, I don't think so. But in case of needs, it can be modified, I mean, according to our needs. It's quite flexible, obviously. Okay, if there are no other questions, I thank you all. I leave the floor to Jacob here with his supply-side model of the Maltese economy. Thank you.
Good morning, everybody. So, today I will present the supply-side model for the Maltese economy in a semi-structural framework. Of course, this is just my point of view, not necessarily is the point of view of the Central Bank of Malta. So, during this presentation, first of all, of course, I will explain why do we need a better supply-side model and which are the challenges for this supply-side model. Then, of course, we don't have time to go equation by equation, so I will just give you an overview of the model to get the flavor. And then, of course, we need to check if the model works in the long run, given that the supply side usually leads to the long run. Then there is another point, crucial point. What happens if we change the drivers of the economy? And then, again, which are the challenges for doing this? Before concluding, then I will go quickly through the productivity shock. Okay, so let me start. Of course, here in the Central Bank of Malta, we have already, let's say, a main macro model that accounts for, let's say, a large demand side, but there are some issues on the supply side, or at least is not so. There is not so much theory behind. So, of course, the first motivation is to have a new model that, let's say, that can be used to fund the new macro model, and this needs, of course, to converge properly, as we expected, and then that at the end of the horizon, all the gaps are closed. The other motivation, that is probably more relevant, is that in the recent years, Malta has grown a lot. But when I estimate a model, so in my case, for example, the estimation period is from 2001 to 2023, of course, my model, if it works, will converge to the average, the in-sample average. For example, we have, there are usually three drivers: the demographic driver, the inflation target, and the productivity. If we consider, for example, the growth in labor force, we can see that the in-sample was 0.74% growth, Q-on-Q. This, let's say, is way above the European average. And the crucial point is that the projected growth for the next 10 years, both the in-sample and the Commission, the European Commission, point to something, let's say, a bit lower, 0.45. But here the point is not so much about the precise figure. The point here is to create a tool that is able to capture a different trend out of sample. So this is the second motivation. So As I said, this is a semi-structural model, meaning that, as the name suggests, there is a structural part that comes from the theory and led the long run, while there is the demand side that is based on estimated relationship between variables. So it's a bit less, let's say, theoretical. These kind of models are used for the short to medium run exercises, projections, IRFs. There are, let's say, one of the main characteristics is that there are two different types of variables, the target variables that usually comes from the theory, and attract the actual variable that depend on the, let's say, on the short run, to the long run. And to conclude this part, we have two different kind of expectations. We have adaptive expectation, as in stream, that is the core macro model here, and my supply side model, while there are various expectations for ECB base or FRBUS. My model is a short scale model, given that it accounts for 40 estimated equations and 32 identities. Usually this kind of model accounts for 300 equations, more or less. The idea here is that to check if the long run works, we just need the supply side and a bit of the demand. This is why, for example, I skipped entirely the fiscal block and the majority of the financial block. This is important because when I will show you the RFs, then there is this kind of caveats. The estimation period, as I said, spans from 2001 to 2023, and the supply side, that is the core of the model, comes from ESCB multi-country model, while the demand block is a blend between MCM and stream. So this is more or less a schematic representation. Of course, it doesn't account for all the variables, but this to give you, let's say, an idea. In yellow, we have the targets, investment, potential, GDP, Nairo, productivity, and on the demand side, the consumption. So we can maybe start from investment. Given the target for investment, we have two different investments, dwelling and non-dwelling, and thanks to two different motion of capital, we have housing and non-dwelling capital. The sum of the two is crucial, given that is the total capital that enters in both sides of the economy, on the potential, in the potential GDP, together with total employment target and productivity, and so on the supply side, and in the demand side, in wealth, and then in the consumption target. This variable is really important, so keep in mind, because it will be relevant for the productivity shock. And this consumption target is a function between disposable income and wealth. So given the demand side, so the GDP components, and given the supply side, of course, in the short run, the output gap would be open, but then in the long run, needs to go to zero. When this happens, there is another side of this representation that goes to zero, that is the other gap, the unemployment gap. As the name suggests, is the discrepancy between the actual unemployment and the long-run unemployment, or Nairo. Until this gap is different than zero, there are pressures on real wages that then cannot converge to productivity until this is closed, and this has an impact on the disposable income and in all the deflator, given that this is my main price in the model. So, okay, so now that we have an idea about more or less how the model works, let's see if it converges properly. First of all, we need to understand what's the expectation, so where we need to converge. These are the free drivers, so we have the demographic variables. All the demographic variables should converge to the growth rate, in sample growth rate of labor force, that is 0.74%, real wages and productivity to 0.2, that again is the growth rate of real wages. Around prices, given that this is quarterly, is 0.5, that is the ECB target, or 2%, And it's possible to demonstrate that all the real variables need to grow as demographic plus productivity, so 0.74 plus 0.20, that is equal to 0.94, or more or less 4% per year. And this is the case for my model. As you can see on the left-hand side, we have the GDP components that together with GDP, they converges to this 1%, while on the side of the deflators, they are converging in the long run to 0.5. And this is also true for the gaps. So on the left-hand side, we see that the GDP potential attracts the GDP, and then together they converge to 1%, while NAIRU, even if it's a bit volatile, so this is a caveat, but on average is around, unemployment is volatile, and on average is around NAIRU, so still the gap is closed. Now, that we understood that the model works in the long run, we need to understand if it's possible to modify one of these drivers, no? And what's the ramification of this choice. Look, if we, for example, want to modify the population driver from 0.74% to 0.5, we see that the framework breaks. So, in other words, in the long run, all the gaps are closed, and then all the variables are growing to something different than what we should expect. And the reason is the following. So, we are forcing the model to grow to something different than all the rest of the part of the equation is pointing. So, in other words, all the model is estimated, so all the betas will point to the direction of the in-sample growth. So we have a kind of an imbalance between the left-hand side and the right-hand side of all the equations. There are two ways to, let's say, avoid this issue. So the first one is, for example, we're talking about population. We divide all the model for labor force, we run it, and then we multiplying ex post for the path that we like. But then, if we want to modify productivity, then we need to do the same, and so on and so forth. Given my laziness, I created this adjusted method that, applied to all the equations, you can then modify as you wish the drivers. Of course, the results of, for example, a per capita model when you change population and the adjusted model are completely the same, so I can use both. Okay, until now, we spoke about the long run. So, but what happens if we modify one of these drivers one-off, so for just 1 quarter? For example, let's see a productivity shock. So, if for 1 quarter I have productivity that grows by 1%, then we can see maybe, I don't know, here, okay, that as we can expect, the real compensation per employees jumps immediately to 1%. Of course, as I said, productivity and real wages are interconnected. The point is that we should expect the same for all the real variables, and more or less, for example, for investment, this is the case, for export as well, and so on. But, as we can see, real GDP is not growing precisely at 1%, but a bit below. And if we check consumption, it is way worse. So it grows by just 90% of the shock and not 100%. The reason is the consumption target, because the consumption target, as I said, depends on 2 different forces, the disposable income that jumps at 1%, but also wealth. And wealth takes time, given that it is a function of capital. For this reason, given that we have the deflators that are sticky in the short run, as you can see in the bottom right, the GDP deflator doesn't move on impact, we have kind of a situation of oversupply. This implies a decrease in the deflators and in wages, that, for example, for wages, they start to decline from 1 to 0.8, and of course, this, given that on one side, we have the cost of capital that is increasing, and the wages are, let's say, decreasing, implies a total employment that goes up, at least at the beginning. The last crucial point in the short run is that here the central bank is exogenous, so it doesn't play a role, and the point is that the interest rates, the nominal interest rates, then are fixed But given that we have deflation in this economy, the real interest rates are going up. In other words, we have a real tightening. And we can see the ramification of this on investment, because it goes from 1% to 0.5 after just 4 years. Anyways, this is the short run. Then in the long run, if this is a productivity shock backed by demand, all the real variables and compensation per employees go to 1, while total employment revert to 0. Now, to conclude, as I show you, the model works, and it's we have a defined long run. Moreover, we're able to let's say perform these different kind of exercises for mainly on the supply side, for the long and the short run as well. And looking forward, then the idea is to use this one as a foundation for the new macro model. So by enriching it with the entire demand block, and moving the expectation from the adaptive expectation to the VAR expectation as in ECB base. And that's all. Thank you for your attention. And I'm here for your question, of course. If this is the case, enjoy the break.
Welcome back, everyone. So for the second session, I am pleased to invite Chiara Obstat on the podium for her keynote speech. Chiara is advisor at the Monetary Policy Research Division at the European Central Bank. Prior to this, she was advisor at the Prices Division, where she co-led the price-setting microdata analysis, or PRISMA project, which has initiated the collection of price microdata. Chiara's research interests revolve around using insights from microdata to answer macroeconomic questions, and her projects are quite varied, ranging from the calibration of large-scale multi-sector, multi-country, and multi-region models to the estimation of pass-through of tax shocks to prices. During her talk, she will talk of the opportunities and challenges associated with using microdata for macroeconomic analysis. And also the talk will be followed by a separate Q&A session where you can ask and raise your comments to her. So Chiara, the floor is all yours.
Thank you so much for inviting me to give this talk. I have to say, this morning, walking to this beautiful building, I was so impressed by Valletta and feeling the weight, but also the support of the history of being really in the middle of the Mediterranean. But now I'm even more impressed by the centrality of the work that has been done at the Central Bank of Malta on topics, research topics that are of interest not only to this public, but to the whole European Eurosystem staff, and in general, of course, to the wider academic and central banking world. I've been invited to talk about, in general, kind of considerations on the usefulness, but also on the difficulties of using microdata to answer micro questions. And the first thing I thought is, well, there is old microdata, but there is also new microdata, and I'm going to keep this kind of dichotomy throughout. Before I start, of course, I have to say, like everybody before me, that whatever I say today is just my ideas and not necessarily those of the ECB or the Eurosystem. As I said, why do we use microdata for macroeconomics? What microdata, and how can we use them? I'm going to give you a bit of a personal considerations and accompany you through reminiscing my personal journey with colleagues through this why, what, and how. And having used both old microdata and produced and used new microdata, I'm going to also focus a little bit of that. And the guiding principle here is my own personal research question, which has been in the last 10 plus years. Does inflation respond to shock? How and through what channels? So again, I will go first through the why, then through the what, and there are some considerations of old and new microdata. And then on speaking about how, I will give a by far not comprehensive view because it's only guided through some examples of my own work with colleagues. And I finish on considerations on the challenges and opportunities for all central bankers, but in particular trying to imagine or assess the pros and cons of working on this from a small central bank. Again, cons, but also pros that I don't know if you also see all the opportunities that you have in addition to the challenges. So why? First of all, modern macro is empirically micro-founded, depending on how you call modern macro. It's not only since Lucas that we start to micro-found, but then progressively we also walk away from the representative agent assumption, which is, I would argue, the point on which modern macro is most strongly criticized, especially by outsiders. So quite unfair criticism, I would say, in light of the literature of the past many years by now. And then there's another why, which is completely separate from macro modeling, the SGE, and say deep research in that environment that is maybe closer to what we do as central bankers in terms of monitoring. In my case, inflation mostly, but any other macro variable, which is with the deluge of big data that has been growing and growing, and the technological possibilities to collect them and analyze them, we also use big microdata generated by sometimes ourselves even for empirical macro analysis, monitoring, and as we saw a great example this morning, forecasting and especially nowcasting. Now, look back at the part on how to use microdata to discipline macro models. First of all, you need microfacts to microfound the SGEs, and especially for relaxing representative agents assumptions, because once you relax, you have to think about heterogeneity, and then what dimensions of the heterogeneity, which one is important, which one is vast, what is available to discipline a model, you have to go to many sources of microdata. And in red here, you see a point on distributional and incidence question is particularly important for central bankers to understand the various channels of monetary policy transmission, and the CHAMP research network, which is heading to a close, covers many studies on heterogeneity. In general, when you see red, it means that I'm going to talk about it later in my examples of own work. So microdata allows us to answer the question, who adjusts prices, wages, portfolios. We've seen an example before about portfolio impacts on across wealth deciles of monetary policy. What sectors and what firms and in which countries drive inflation and output? How do policies, again, affect different households and firms also in regions, and again, via what channels? And the benefits of combining the microdata, which just give you facts, with the macro models, we give you a structure to think about these facts, is that you can now see whether these sources of heterogeneity wash out, which is basically the premise of representative agent models. Everybody's different, but on average, I don't care. I think the key message of the past research is like, well, you have to think very hard about under what conditions do I not care and under what conditions do I have to care. And that's the richness that these models paired with this microdata bring. Then we faced various stages in which the SGEs had to move away from kind of a linear world, which is, again, Gaussian linear, you can call it, a world in which everything washes out and you just look at the mean, we had zero lower bound, and then suddenly we had large shocks. And the models were not equipped coming out of periods of low inflation to deal with what do I have to change? First of all, do I need to change anything when the shock is large? And what is a large shock? How can I tell? I will speak a little bit about that. And the micro behavior then is crucial because some models tell you if you see this in the microdata, then use that model and not this model. And again, I will show you an example of that, which we use for the recently closed strategy review. And then on the other side, you also can choose, once you have these models, and again, the importance for a central bank of building models and different models and a portfolio of models, coupled with this daily information, daily, weekly, monthly, as long as it's not annual information on the micro events, tells you, this is a period where you can be linear, because we are in the linear world, or wake up, this is when you have to pull up the other model, because the linear world is not helping you. Now, in terms of the granular data, we've seen, again, example this morning. I've personally used as well online prices and web scrape data to monitor inflation. So far, we're not yet at the level of implementation and comparison with an IP and that you have here in-house. And I'll show you a different application that we did. But it's a long history, I think, with Cavallo breaking the mold for monitoring how accurate the Argentinian Statistical Institute was measuring inflation. That was a long time ago already. But recently, I have to say, I've seen it mostly from within the Eurosystem. There's been a lot of investment and now applications of web scraping for monitoring inflation. Today, we saw a much newer one, and I think you also quoted Pavel and others. Then there's search data. I cite only one paper because I know it a little bit better, but there's a lot more for consumption. There was an old Google-originated paper on forecasting the present or predicting the present, but Damuri and Marcucci, again, from Banca d'Italia, so Eurosystem result, use Google search models, Google search trends to forecast unemployment. Then there's been a period, I think, especially in the run-up to 2020, you saw a little bit, but afterwards it's been an explosion through the COVID when we were kind of struggling to understand what was going on, of using high-frequency transactions, especially credit card data. Those who could get their hands on credit card data and payments data in almost real time really used them very much to nowcast mostly consumption, of course, and hence GDP. But we also have household and retail scanner data, which are very good for consumption. The problem for us is they're not available to us, but those who had them available also use them in real time. For us, they're only available with years of delay to look more at structural issues. And then we have the explosion of text analysis, which was going up linearly, I think, until LLMs, and then it became exponentially. Once you can feed text to the master of text analysis, which is the LLM, you have all these policy uncertainty indices, a cottage industry of using, for example, conference calls to extract sentiment about trade, sentiment about Brexit, I mean, sentiment about pretty much anything. And I will close the talk actually with an example that comes from the Central Bank of Malta and the Eurosystem. And then a lot of this text analysis, but also multimodal nowadays, deep learning multimodal has been used to tease out either the tone and the sentiment in the central bank speeches, even faces, even videos for the Fed, or to tease out the impact of central bank talk on the public and different parts of the public, and that's where my colleague Michael Herman gave a contribution. So on this, I have to say it's much less of my own work, but I wanted to give an overview that there is also a lot of new, especially microdata using for that. Now, back to the old. What do I mean by old? I mean, in this audience, I don't have to explain too much, but basically we have surveys, we have firm level data, we have administrative records. And then I just talked about, it's micro, which we make out of big, and big data is like, not just that it's large, as in terabytes, but it's a lot of volume, that's how large. It's very quick to accumulate, and it's very various. And a lot of our job is to get that, like, again, Massimo, Sara, and Umberto do. You get this big data, you have to organize it, you have to classify it. That's a big hurdle for us as users who have become also producers. Now, just an overview, again, speaking to this audience, you are very well aware. But what is the main difference between the old and the new? So the sources of old microdata are mostly household level surveys, firm level, administrative records. What is special about them is we sometimes have long histories. We tend to have stable concepts because we may be frustrated sometimes, personally sometimes I am, with the speed at which statisticians decide how to do things. But once it's decided, they do it well, and we can really rely on it, and we can go back and understand and apply. And these kinds of data, because of how long and stable they are the backbone of many macro facts, or micro facts that we use for macro models. Now, the household level surveys, for example, they cover income, consumption, labor force, a lot of expectations. And again, the questionnaires, we really try to keep them stable, otherwise we lose the time series. Firm level data often come directly even from administrative credit registries or business registries. And again, surveys, we're asking about expectations, we're asking about realization on the real side and the nominal side of the economy. And then again, it's an explosion, especially in Scandinavian countries, on administrative data, because somehow they must have such huge trust in the government that they accept that all these administrative records are matched. And for researchers is a treasure trove. As a citizen, I mean, I respect the trust, because we really have to keep this trust as citizens to accept that all our data are really feasible. And I'm talking about a recent application, for example, to discipline macro models with Norwegian data, in which you have the income, the wealth, and the income both from labor and from non-labor, and the individual consumption via credit card, on payments card, and so on, and you match that. So people really, I mean, we're kind of anonymous, but they know everything. The new microdata, this is a growing source, and again, it's virtually unlimited coverage. But in order to use them, you need to collaborate a lot more, not only among economists and statisticians, but suddenly we have to integrate with the data engineers and with the IT in a way that we didn't do, even personally not 5 years ago. And this is, again, web scrape prices. We've had a presentation this morning, but we also have the transactions data. We have high-frequency labor market data, like we use a lot Indeed, on job postings, what kind of jobs, what wages, what frequency. And there is all kinds of things that you can get, for example, from Twitter or other social media at the moment. You can scrape them. But then there's also data that are created by activities, not just kind of language, for example, like shipping, logistics. I have colleagues who now have an index of to nowcast industrial production using satellite data. You can look at daily illumination, electricity consumption. You can literally monitor GDP in real time using this data. Again, to collect them, to understand them, to use them, needs close collaboration, especially with computer scientists. Now, in an overview, what are the opportunities and challenges to sum up this part on traditional versus new microdata? Traditional, again, it's stable, clear sampling frame. The statisticians do their best to give us data that do not suffer from selection bias. You have very strong metadata documentation, so you can trust this data. And in principle can be matched across data set, not by us, but by the collectors who can be trusted to do that. On the other side, you have the new microdata where you decide the frequency sometimes. It can be even intraday, and you can cover many products, many firms, many locations. You have control of that, and so the design is flexible. You do pay a price for this flexibility of design to craft the data the way you want them, but the fact that you have no control on how they are, so the raw data are produced, which means, for example, you mentioned, I think this morning when I started collecting daily prices from websites, I assumed that a supermarket would always use the same kind of ID for a product. Don't assume that, because some have changed it like 5 times in 2 years. So you get no uniqueness, you have all kinds of problems which derive from the fact that we have no standard for collecting this data. We're just kind of fishing with nets and then seeing what we caught. And of course, you have to choose what to scrape, and you do not choose it in a representative way. You can never aspire to be representative. You can at most check if it is indicative of the process that we want to study. Now, this flexibility and the kind of challenge of this new microdata correspond, however, or are complementary to the challenges that you have with the old microdata. So they're easy, they're perfect, but the price of this very good reliability is usually that it takes months, sometimes years before the statisticians are done and hand them to us. And some specific phenomena that we would like maybe to study, they are just not covered, and you need to then change regulations to start covering them. So one of these things, for example, is dynamic pricing. We all care about it, but it's unobservable from the traditional data. Now, for me, I'm a big fan of the SCB, in case you have not yet realized, but when you look at the value that as a system we have produced in terms of data for the wider profession, we have collected data by surveys on the HFCS used this morning, and I also use it in one of my projects, the SAFE, the CS, which is not only just collecting information, but doing all kinds of randomized controlled trials. The wage setting, where Malta was also participating, as is in the HFCS. Then we had the price and wage microsets, Prisma. I had the honor to co-champ. And now with CHAMP, we're not collecting new data, but we're actually made an effort to connect data. For example, we connected Anacredit with Prisma to see to what extent financing conditions of firms can affect their pricing. And then we have all regulatory supervisory data where I personally never worked, and this is not exhaustive at all, but every regulation we generate also corresponding microdata, which are very much used. And then we have this big data micro data set. I've talked at length about the web scraping, but we also have hackathons. We started actually our web scraping with a hackathon in 2019. I think it was the second one that ECB ran. But now there are more regular ESCB hackathons, and they have tended to be catalyzers also for the production of new indicators. So the how. Now we come to the point where I give you snapshots from my micro for macro journey, again, accompanied by many great colleagues. And the beginning for me was to look just by policy question during the surge, who wins or loses from inflation. It was a big topic, and it continues to be a big topic. And then some colleagues ran with it and used microdata to go really deep in it. That's the first thing I will show you. Then I've been working about the extent to which market power affects the pass-through of various shocks to inflation. And now, in the past year, CHAMP brought me for the first time to work with the SGs, and in particular then discipline in the SGs. And I think I used most of those networks, WDN, Prisma, HFCN, to calibrate this model. I will show you a little bit of that. So, who loses from inflation? Why? Research question. Who gains and loses? What microdata? We, in the top two charts, just published an article in 2023 where we didn't have microdata, or we didn't have the chance to use the microdata. And we just looked at the components of inflation and the different weights that Eurostat gives us for different quintiles. And since energy was by far the highest relative price difference, it really mattered who consumed more energy. And it turns out that we found that the poor, like to call the first quintile of the income distribution, which is not all poor, but let's call them the poor, was suffering more. Then colleagues from the research department took instead the GfK Kantar household panel data, which tell you not only the prices of the supermarkets, but also characteristics of the people who bought them. And then they were able to compute inflation rates for various chunks of the income distribution. And they found this, let me see if I can point, these two lines. The blue is a last pair index, which means last year's basket. And the PASH in gray is this year's basket. And you see that at low inflation, the last pair is lower for the rich. So on the left, the blue is lower. But as at low inflation, there's no difference. And then as inflation rises, the rich inflation is relatively lower than for the poor. But kind of the opposite is true for the PASH. So what does it mean? One thing I observe at 2%, the average of the two, which is kind of a Fisher index, which is a cost of living indicator that is not the way we compute HSEP, which is last pay, but it aims at catching the substitution bias, is more or less 0, which means we can to some extent. But as inflation gets high, the poor are the ones who pay the food sold's cost of going around shopping more for occasions, for sales, changing shops depending on what they want to buy, buying in bulk when things are on sale. And basically the shopping habits of the poor are more reactive because they're more elastic to price, and hence this gap changes at high inflation. That was just looking at inflation. The next thing, actually in terms of time, it was happening at the same time, but the next logical question is, okay, what shapes the response of inflation to different shocks? And one particular aspect we looked at is high markup firms, low markup firms, do they behave differently in terms of transmission? And at the back of our mind was the story coming from outside, from the academic world, that the markups have increased tendentially over time. And if we find, so our question was, will we find that because of this secular increase in markups, inflation has become less sensitive to shocks? And this was the background of our study. We used, in this case, in terms of microdata, the firm balance sheets for all euro area countries from 1995 to 2018, and we used the Orbis for that. And how is to get externally identified shocks. So we took an oil supply shock and global demand shock, and then a monetary policy shock. And we just estimate, first we had to estimate the markups, which involves firm level, supply function, production function estimation. And then we aggregated industries. We said, okay, this industry has firms that has higher than 30, say, is in the top third of markups. This industry has firms that are more in the bottom. Let's aggregate them. And then we find normally inflation will go up after an oil supply shock, after a global demand shock, and also maybe not so significantly after, this is PPI inflation after a monetary policy shock. And if you take the difference in two-digit level between the low markup and the high markup sector, you see that it is the low markup sectors that are more responsive, which to us pointed to, is it that they have such thin margins, so the markups are so low, they're so thin, they cannot absorb, so they have to pass on the prices. But this is then, I will show in the next slide, kind of at odds with another study that we did on a totally different question and very different data, with one of the co-authors is in common. And this mechanism is not yet clear to us. Why? Because then we had a natural, not a natural experiment, but a great lab in the German economy, because in Germany, corporate taxes are decided at the municipality level, and that's a very, very granular level. So every year, by the end of the year, every municipality will declare what kind of top up to the average rate they will put. And we were able to match from supermarket scanner data now, from IRI, which show us every week, every single supermarket in Germany, the two-digit zip code, and the prices of all their goods. So we were able to match the barcodes to firms going via Orbis and GS1, and then the headquarters of that firm is in that municipality, so we know their tax. And then we only looked at the prices charged by, say, a local sausage producers for their sausages outside of the taxed area, actually of the zip code even, which means that basically we were looking at the impact of the tax rate on the exports to the rest of Germany of these firms, which were not influenced by the local demand conditions. And this makes us much more structurally safe in identification, and we found, as you see, that there is a big pass-through of corporate taxes to the consumers, which means we eventually pay a third on average of the impact, which is quite a lot. And then we looked, but does heterogeneity matter here? And here we have, with these kinds of data, we have all kinds of fixed effects. And we found by firm size, which was the first suspect, yeah, but in a strange way. But then when you look at the product market share, and you can define the market share product by year by region, product by category, region, year, you see a basically linear relationship. So the higher the market share of the product and the higher this pass-through. And what really matters also a lot is the share of a given retailer for that sausage that year in that market. So it's not only the market power of the sausage producer, but it's also the market power of the supermarket itself because of double marginalization. And just to make a pause, I mean, imagine doing this kind of detailed analysis without this data. It's just impossible, no? You remain at the step that we had before, which we only saw the market, we only saw the markups of the firms, but then everything else we couldn't control. Here we could really control everything, and that's what led us to go deeper. Now there's the other big area is how do you use micro facts like the ones we just found, like pass-through increases with market share, to discipline macro models. And here you have, on one side, the calibration and estimation, for example, of frequency and size of price changes, what are the consumption baskets, distributions of income and wealth like we saw this morning, firm characteristics. And then you also have something I never worked on, same kind of analysis or same kind of data for financial frictions. And then you can be using it to estimate by matching cross-sectional moments, you can match, like we will try to do, we're not yet there, impulse responses by sector and group in the data to those in the model, and then indirectly estimate the parameters of the model. But again, you can also have a suite of models, which we should all have, and then the microfacts, which you observe ideally in real time, allow you to choose which one you want to weigh more. So on the charts, I have the annual frequency of CPI changes coming from Prisma Eurostat. So from Prisma, you know, COICOP by COICOP, the frequency of price changes in every country. And then you aggregate it with weights. And the weights I take from Eurostat by quintile, and I can get an estimate of the first quintile of households in Italy has this price, faces this kind of price rigidity. Now, for Malta, you see that it's very small, but the reason is that I had to give the average to Malta because I do not have the CPI price frequency for Malta from Prisma. So I have the weights, I have many things, but I missed that particular weight. While on the lower side, you see the wage dynamics network, so the annual frequency of wage changes, where Malta actually produces data. And here, it's very small, but what you cannot read probably, if I can, ooh, this is complicated, is that every color is a different kind of job. So you have managers, operators, elementary occupations, military, which I match to what WDN gives us in high skill, low skill, medium skill. And WDN gives us two questions that you can match from a firm. A firm tells you, this is my main occupation that I employ, and this is the frequency at which I change wages. And putting it together, you then can get kind of a different frequency of price of wage changes for different kind of occupations in different countries, which is what we use for the model I will show you. Before I show you the big model, however, coming back to the first presentation of today, we used the web scrape data together with the Prisma data on HICP to characterize price setting. So this is more of a structural question than nowcasting. It may be less sensitive to classification, which is being for us the hurdle in applying first to nowcasting. And we have DPD is only covering the 5 largest countries, and it's 22 to 25. In the top, you see some charts we published in a box in the recent, one of the 2 occasional papers that represent the views of the staff on the strategy review. And we saw from the HICP microdata that there was this increase in the repricing frequency, especially increase in the frequency of price increases. They couldn't go, however, beyond 23, 24 because of the delay. What we could do is observe it in real time. So ex post, this is May 25, we could see that, yes, the repricing frequency has gone up. It has gone up until inflation peaked, and then it came down quite fast. But with the data on the far right, which are scraped every day we had like 2 days ago frequency of price changes. And so we were seeing, unfortunately, not going up because we started in 2022, but we did see it very quickly when it was coming down. And then we were able to say, oh, this is when the sacrifice ratio is coming back to normal. Because when you have a very high pricing frequency is where you have a low sacrifice ratio. And you can say, well, if you believe in such things that the models tell you, this sacrifice ratio is coming down. Then we saw a little bit ticking up after the announcement of the tariffs in April 2025, but I think now this has also come kind of hovering around the more normal averages. Why is this important? On the lower side, I show you 2 charts which are in the same box from a model which I encourage you to read because I think it's very illuminating, by my colleague Anton Nakov and Michel Gassibe. What they have is they put together a model with the production network on the Gassibe side, and then Anton is a big expert, I think world expert on state-dependent pricing. Put these 2 ingredients together and you get, when the size of the shock is large, the frequency of price changes will go up a lot if the shock is a supply shock and if you have a production network. let's take for granted where we have a production network that comes from the data. So when you cross these two things, this tells you, we have a supply shock, it's large, and let's look at when it has washed out, because we will see it in the frequency of price changes coming back down to normal. And I think for me, I've contributed a tiny part of it, which is just the frequency of price changes in DPD, but the impact that you can have by matching the knowledge from the data and the structure that a model gives you is, I think, for policymakers, super important. And when this was presented, somebody asked, but how do I know if the shock is large, if it's supply and large? And then the answer was, look at the repricing frequency. If it suddenly goes up, the shock has been large in a new cost model. This is even more complicated charts, but I will tell you the story. This is what we're doing now for a CHAMP. It's a CHAMP cross-country project where the question is, does heterogeneity change the aggregate and distributional impact of monetary policy? And the microdata we use here is PRISMA, WDN, HFCS, Orbis. So really a lot of data to do what? To extend Elisa Rubbo's model. So Elisa Rubbo is like in the lineage of Fari, Emmanuel Fari, so bringing the granularity of the supply chains into macro, and in her case, particularly into new Keynesian macro model with price rigidity. And more recently, she extended her model to the US with also saying, you don't just produce with one kind of labor and one kind of capital in every sector, but every sector uses many kinds of labor, many kinds of capital. And that's why I showed you the wage rigidity of many different occupations, because we now have calibrated this model to 20 euro area countries, so all the euro area countries. Each of these countries has 62 sectors. Each of these sectors employs 10 kinds of labor, like agricultural, managers, military, and 10 kinds of capital. So you have dwellings, you have non-residential capital, you have software and databases. And you see, in principle, the power of this in telling you really granularly what's the impact on monetary policy. The key takeaway for now is that the distributive impact of endogenous distributive impact on monetary policy can be very strong. What we found so far across various counterfactuals, and I will tell you a little bit about the charts, is maybe on aggregate, not so much, or maybe we haven't found yet a calibration that can deliver a big aggregate difference in the aggregate impact. But basically, the starting point in the top is reduced form regressions. It's basically local projections of GDP, employment, labor costs, wages, HICP, and consumption on a monetary policy shocks across euro area countries. So you take the aggregates of each euro area countries and you regress them on that shock. And you see that they're all over the place. So lots of heterogeneity, unexplained. In the paper, we have charts that show once you do it in a panel and you interact the sector, country with, say, price rigidity or labor share, everything becomes much better behaved and you start to understand things. But the level of understanding that a structural model can give you, of course, is much larger. So we're able to generate the same impulse responses from a model, and then we will try to match them to estimate some core parameters that we cannot get from the data, but we have to estimate. But what we found so far in terms of redistribution is, look at, let's see if I can get it. Oops, no, it's like shooting with, yeah, there. There you see the blue and the pink. So the blue is the range of consumption responses of the households that we have in this model. We have 100 households. We have 20 countries. Each country has 5 quintiles of the income distribution. And the range is huge if you have many kinds of labor that these households offer. But if you say, I have only one kind of labor, and you collapse the model to a smaller one with one kind of labor, the dispersion falls a lot, which tells you, okay, labor is driving a lot of this dispersion. Let's go deeper to see in the supply of labor, for example, of each of these. And this was the last of these examples of applying microdata to big macro questions. Well, inflation, if you think that's a big macro question. And to zoom back out on the challenges and opportunities and kind of close the discussion, we're mostly laying out the ground maybe for questions and discussions among us. So the challenges for us researchers increase a lot with the size and complexity of the data. Why? We have to maintain and modernize data infrastructures and storage because the data are large. Pipelines have to be smooth and fast. And then governance. One thing that Massimo didn't talk about, for example, about the DPD, I mean, my DPD, but WebScript data is you have to say, okay, am I compliant with the GDPR? And we had to go via many steps to realize, yes, we are complying with GDPR as long as I organize my pipeline in a certain way. And I have to take a lower level of quality than I would like in order to be compliant with GDPR. And whenever you become a data producer, of course, that's something we take upon ourselves. Managing confidentiality, access, legal constraints. And recruiting and retaining specialized skills, and I think you've been very good at that, if I can say from my little sample. It's important to look around and see where this talent is produced and hire it, and then retain it. And then we have to talk to COICOP, for example. No, so it's really not easy. But again, we pay this cost to have a benefit, and the benefit is that we are much quicker able to detect the shocks, as with the WebScript data. Transmission, we can now tell different channels apart. We get richer evidence on heterogeneity, so we can study which one matters, and this just improves our policy analysis. Now, small countries, like being here, I thought, okay, let's think about, is it easier for a small country or a small central bank, or the central bank of a small country to deal with this, or is it maybe also, say, what are the costs and what are the benefits of being small, so to speak? So the challenge is clear. Many of the things I've discussed, especially, well, both in the old micro and the new macro data, is there's high fixed costs, and the smaller you are, the bigger those fixed costs, the harder it is to cover that fixed cost. So scale matters. You can have, specifically for web scraping, machine learning classification challenges, like the language models have not been trained on your specific language, for example. You can have small sample statistical issues for identification. You need a lot of variation. If you do not have many households or many firms, you do not have that. And then anonymization can be harder. I personally had to struggle when calibrating that big model for medium-sized countries, not disclosing the composition of manufacturing. And I don't know to what extent you have the same. When a big firm dominates an industry, you just don't get the data. But this also means you can aim at getting a comprehensive coverage, like Massimo discussed the coverage this morning. No? You can aim at having full coverage of Malta. I cannot aim at having full coverage of the euro area in terms of scraping supermarkets. But I guess it's easier to coordinate with the NSO when the country is small and there's maybe more personal relationships. And you can be faster in experimenting. I mean, I think you were faster in getting to production on web scraping, for example. And then I imagine, again, it's easier to get feedback from the economy to policy intervention. So we talked this morning about the fiscal drag. Like knowing an economy that it almost can put a name on some firms or some actors, and you can really see you have less noise in a way than a big country, so it's easier to understand the feedback. And I close with this. I think, again, I don't know how many times I said it, I'm a big, proud fan of the ESCB. And we have many communities of practice. Some are just theoretical, like we have workshops on ML. But this hackathon, for example, is one that every year tends to produce some results. I know Sarah's paper that she will present later was originating in a hackathon, I think in 2023. And last week, I was sitting in the new hackathon, which is from news to forecast, experimenting with AI time series, foundation models. The task was take GDELT, which is an open source database of news, which is 2.5 terabytes per year, hard to work with. And Team 3 decided to use it to forecast investment. And your Matteo Panfilo was actually the speaker, the presenter for this project. And in 24 hours, they managed from this enormous treasure trove of news to synthesize various sentiment indices. And here I just show you one where they show the attention in the news about monthly strikes and trade unions. And you see France in blue seems to be a big outlier. I give up on this one, I think. So imagine in 24 hours what these people from across the Eurosystem can do. Just, give them 6 months to a year and just imagine. I mean, actually, Sarah can tell us how long it took to mature from the hackathon to where she is now. And I would like to point out, so we have Sarah example, we have Matteo today. So with the opportunity to leverage the ESCB, a relatively small central bank can really project its intellectual leadership much wider. And just to wrap up, again, we increasingly rely on microdata. We have challenges and opportunities. Some are the same across, some are different. And I think the high fixed cost and confidentiality can be particularly challenging, but the community of practice can at least remove the technological constraints or alleviate them. And on this, maybe on the screen, I'm very happy to hear what you think of these things.
Thank you very much. Can you hear me? Yeah. For your speech. I had a couple of reflections. It's not a question, it was more. So I remember, say 20, 25 years ago when I started becoming an economist, I had the impression that models were actually ahead of data, in the sense that sometimes you had a parameter that you wanted to calibrate, but you could not find the data to. So it was like that the models were sometimes over-capable with respect to the data that we had. Instead now, it seems that the opposite is occurring. So it's like models sometimes cannot catch up, like theoretical models, general equilibrium effects and everything, cannot catch up with the richness of the data that we have. So in a sense, the speed of data production vis-a-vis the speed of model production and theoretical model production, it is completely reversed. And it could become, because to develop a new model takes really a lot of, so LLMs can help you to set up, but if you have to generate a new idea, to put a new mechanism into a model, it takes a lot of time. So in the light of in the profession, I wanted to see if you agree with this global view, and if basically we maybe need to rethink, in a sense, the graduate school programs, because I had a recent conversation with one of my former advisors at my PhD program, and basically, if you look at the first 2 years graduate courses of an economist right now, there is probably 90% overlap with the text work and the things that I had been doing 20, 25 years ago. And only when you do a research, then you start to explore new techniques and everything. But, so I'm saying whether as an economist, maybe we should try to change our training a bit so that we can adjust our modeling capacity and to the production of new data. So if there is a sort of model data gap that probably from our training of our new graduate students, we should try to do something to give inputs in order to close that gap and have like theoretical models to match the production of new data.
That's super interesting. It lights up two little lamps in my brain. One is that it's more of a circular thing, I think. Like if I think when we started Prisma, it was literally coming out of the presentation of the LIFT report. The LIFT report was low inflation a task force report to the governing council, actually the general council. And one of our closing points were to really get to the bottom of why we're having such low inflation, we would need microdata. And then with that in the minds of the governors, we proposed, give us money, give us resources, we will get the microdata to answer the question we got. So the models that we had at the time of the LIFT report were screaming for, I cannot tell you the whole story, get a model that can, and that model will need microdata. So it's circular, right? So somebody thought about heterogeneity matters, and then two things happen. One is the technology allowed to solve models that are more complex, and the same technology allowed to get data that may be useful. But I think there's also an impact of the model developers on the community to decide where to put the resources in terms of getting microdata. So I don't see it so parallel, but actually like a circle. And in terms of rethinking grad school, it's just a sense, I have never quantified it, but I have the impression that the length of the authors list on economic papers is not catching up with science, but it's increasing. No? Scientific papers are like 20 authors. Economics, more than 3, like, somebody was not working there or something, no? And now you have 6, you have 8, and I can guarantee you on this last paper, we have many people. Why do we have many people? Different skills. So you can take it in your line of thought to say, oh, graduate school should teach me also data engineering, and then it should teach me more about statistics, or you can say economic programs could be embedded in labs, like natural sciences have labs, and the lab, I guess, has the empiricists, the theories, the lab technician. So you can go both ways. I'm not sure, maybe with LLMs, that a single brain can do all these things, but certainly a group can. So maybe that's more a cultural evolution than a specific teaching evolution that we need. And I guess you see it like we all see it in the way we work now. No, we're more integrated with others. Yeah.
Can you hear me? Yes. So thank you, first of all, for the very insightful presentation. I certainly take away with me a lot of information. I wrote down 2 points. One regarding challenges. So it's more of a philosophical question for me, a philosophical debate in a world in which, you know, every kind of data becomes accessible, you know, and every combination of words becomes accessible with LLMs. It's like Borges' library. You can choose whatever book you want. Sorry. Some have meanings, some do not have meanings at all. So the role of the researcher becomes, I think, even more pivotal because you have to choose the right questions. Otherwise, the risk is losing yourself in avenues that take long, that do not tell you anything. And this is my personal view, but for example, with text, I saw a lot of papers about sentiment, about this kind of thing. Okay, stylistically very nice, but what are you trying to say with this? Is it really important? And given that computational resources are becoming more and more accessible, faster and faster, I think people tend less to ask this question of why, while instead, some years back, even 10 years back, you were very constrained by computational resources, so you really had to jot down the model, think about what you were trying to answer. So I see this challenge a bit in the scientific world. And regarding another opportunity, so I saw in some other social sciences right now what they are doing is trying to use LLMs to construct synthetic data, so data that you do not yet have. So for example, you give some persona characteristics to the LLM, and you tell him what would have been your behavior under this circumstance. So this is another point that I think would be valuable in the future to explore. At the moment in economics, I don't think it's done. I don't know if the properties, work. There is a lot on the theoretical econometrics, but yeah, these were more remarks than questions. I would like to know what you think about it.
Maybe I start with the second. There is also in economics now this. So LLMs, it's on surveys. I apologize, I don't remember the name of the authors, but it's a paper that's going around quite a bit across also the EconDats conferences. And they say we generate a persona that responds to the survey. But then we go back to your first point. Okay, so what? No, you've generated an artificial persona, it responds to a survey in a certain way. My personal reaction when I saw a very short presentation of that paper, not that paper, but another paper that does the same. So we generate artificial, basically increase the size of the survey, but generating artificial responses that somehow are disciplined by the rest of the survey. My reaction there was, I think it would be more interesting to ask an LLM, maybe you have a DGP in the world in your weights, in your billions of parameters. If I give you these responses by real people, and I give you two alternative models. For example, easy one for consumers and inflation. Inflation is supply side, inflation is demand side. So I give you these two models, I give you these answers, and I ask you, what is the predominant model in the minds of these responders? I think that would be a more grounded way than just simulating responses and hearing about the reactions with colleagues from these papers that generate the responses. It all seems to be in the then what are you going to do? However, here I see a very stark difference, again, coming back to why. If Y is getting very good forecasting ability, I don't care. I forecast. And that's where data scientists are coming from, no? Like prediction. They call it inference, which becomes a little bit complicated, but there's no inference from the point of view of an econometrician, so you're not telling me anything about how the world works or why this happened. You're just telling me I'm doing very well. And then I think it's very useful because you can use that as a benchmark for another forecasting model that tells a story and you say, look, I don't do much worse than this fantastic forecaster, but I also have a story and an explanation and a causal explanation maybe, but you establish the credentials against the one that is just telling you a very good forecast without knowing why. No? So that I think there is this, both have space. But again, you go back to why. Why do I do this model? Do I do it for forecasting? I don't care. Do I do it to make decisions to change the world? Then I care. I hope I replied. I don't know how we're doing with time.
We are past our allotted time, but if there are any other questions, we can.
Then it's time for me to thank you again for the chance to be here and the chance to think about these things. Thank you so much.
Welcome back. Welcome back, everyone. Let me introduce the final session that we have for you today. We will now listen to two presentations. The first one from Theodosios Drossidis, who will be presenting the last article that featured in this year's Research Bulletin. In his presentation, Theo will be looking at how temperature and precipitation shocks in Italy can spill over and affect economic variables here in Malta. After that, Sara Spiteri will present her work on how we can integrate climate-related data in machine learning methods in order to explore region and sector-specific vulnerabilities to climate events. We will also be having a Q&A session after each of these presentations. Thank you. Theo?
Thank you, Noel. And after a very micro-focused morning, I would like to switch a bit to the macro perspective here. And as you see, this work is about the short-run spillover effects of climate shocks to small open economies. For the time being, I'm wondering how I can switch the slides. Does anyone have the... Is it not here? Ah. Amazing. So I think let's start with the important stuff, which is the usual disclaimer. It applies. And okay, let me set the stage. So climate change is a thing. I think by now everyone should be aware of events like drier conditions in general, heavy precipitation all of a sudden, and these more frequently appearing heat waves that we observe. And of course, this has long attracted the attention of policymakers who actually established, I think, a very, very good policy instrument is the Green Deal that targets basically a climate neutral society by 2050. So this is a good example to express the interest, the attention of policymakers into climate change. Now let's focus on more on the economic effects, and such events, specifically temperature and also precipitation, actually reduce, just to give you an intuitive transmission channel here, is basically could be that a temperature or a heat wave affects productivity in the agricultural sector, which then spills over into prices, and we see these inflationary effects, this pressure on prices. And this, which is just an example to make you see the whole bigger picture, how this can transmit to consumer prices, this in the literature mainly has been investigated from a domestic perspective, which means we look at a specific country and we see what is going on if there is a heat wave, if there is less precipitation. And even though the spillover effects of such shocks have been recognized in recent literature, such as from even working papers from the European Central Bank, as you see here, there is limited investigation provided. And this is where I focus on here. I specifically ask the question, what are the cross-border effects, of such climate shocks? And let me give you quickly a motivation why this is important for Malta, because Malta is a very small and very open economy and is highly integrated into the trade with Italy. As an example, if we focus on import shares, since 2015, food imports were never less than 40%, and in the case of electricity, it's even higher. So we see it's clearly more than 90%, which is coming from Italy since 2015, always. And the key question I'm trying to address here is, how does a temperature shock or a drought transmit from Italy to Malta? So Italy faces a shock. What is happening in Malta? And by the end of this presentation, I hope to, let's say, convince you slightly that Maltese consumer prices closely mirror the Italian dynamics, especially for temperature shocks. This is on the consumer side. The producer side also imports kind of the same dynamics, however, to less strongly, the effects are less strongly. And comparing the different shocks to each other, I see that temperature shocks have more economy-wide effects, whereas droughts are hitting specifically are more concentrated on the agricultural sector, which is mainly, for the first one, I have a convolution of shocks, whereas the latter one is maybe more specific channel that is hit by this specific shock. Okay, let's dive into what I'm actually doing. I basically collect climate data, and I built on a large literature of climate studies here on how to derive a proxy for a so-called temperature shock and a drought. And let me quickly tell you a bit about the temperature shocks. The temperature shocks are deviations from a long-term mean of the temperature above the Italian territory. So it's the average deviation from its mean temperature over the Italian territory. Here, I'm looking at seasonal effects. So I split these deviations via dummy variables to have seasonal deviations. This enables me to show results for each season, which is important, as I will show you in a bit. For precipitation, as these results for precipitation are still preliminary, and as can be seen as a first insight in what I'm doing, I derive a drought indicator. So here is a bit more simple to communicate on what I'm showing here is basically, is there a drought? Is there no drought? 1, 0. This is a time series and enters like an exogenous variable, simply. Drought, 1 or 0. And no seasonality. A drought is a drought. It hits always like a drought hits. That's it. That's what we assume. On the side of macro variables, I closely follow a recent publication by Ciccarelli and co-authors who basically collect the breakdown of HICP components. This is also what I do. And I map these for Italy together with Malta. So I collect these here, all the listed variables I collect twice. Once for Italy, once for Malta. I also have producer prices, 3 producer prices, and some production volumes. Always I try to focus, as the study also in line with the paper I'm anchoring on, 2 variables that are closely related to such shocks and are of interest, of course. And then I have also a little block of other control variables. This is mainly because I want to control for general third or second round spillover effects, because I'm modeling only the bilateral, so I only have 2 countries in the model, so I want to control for the second round spillover effects that may come from other countries in an intuitive setting, always. What do I do? Similar to Germano in the morning, I model these variables in a 2-country VAR where I shock Italy and by imposing some restrictions into the modeling technique, I traced the shock from Italy to Malta. This is what the model does. It shocks Italy first, and then the model transmits to Malta, the shock. Specifically, here we go. Okay. Z is the exogenous variable, so think of it as the temperature deviations. This is the coefficient of the temperature deviations in Italy. This is the effect of the temperature shock in Italy. I trace this through Italy, and in second round, I'm interested in this red one here, which is the coefficients of the Italian variables in the Maltese equations. And you see the Maltese variables have 0 coefficients in the Italian equations, which is the small open economy assumption. Some general information to the graphs that are following now in a bit. The observation period ranges basically as long as possible, 2001 until December 24, where basically this is the availability of my data. I use year-on-year growth rates, 6 legs, okay, technicalities, but what I would like you to keep in mind for what follows is that Italy is teal, actually. Okay, amazing. Can we please help me here? So Italy is teal. Oh, this is the wrong. Huh? Yes. Yes. So Italy is teal, or I said it blue, but it's teal. Actually, I have a color. And Malta is red. And Malta is red. So, importantly, Italy reacts first. So when we see the IRFs, we interpret them chronologically. Italy reacts first in horizon 0. Malta follows in horizon 1. Let's start with temperature shocks, where we keep in mind we have the seasonality here. Temperature shocks on HICP components. The general message overall, what you see in these graphs, is that, first of all, in hotter seasons, we see higher temperatures to put pressure on prices. In colder seasons, we observe that, let's focus on the peak seasons here, winter and summer. So a slightly warmer summer than expected, a warmer summer than expected, is taking out the pressure of price movements. Whereas in summer, I see that there is technically pressure going on inflation and driving up the prices, especially if we look at processed food, for example, is the dynamic that I'm currently referring on. Also, with regards to spillovers, Malta is closely following the Italian component. I see similar effects in the red line in each component. The signs are of the same. The signs are the same, and the magnitude similar. Interestingly, Interestingly, the service prices are somehow overshooting in some seasons. This is interesting. On the production side, I see less of significant effects arising, except for energy. And here, the narrative, of course, matches the hot-cold seasons in conjunction with the higher temperature shock, where I see summer is already hot. If I have even hotter temperatures in the summer season, then I actually produce more of energy. Here, the Maltese variables compensate slightly for the movement of energy production in Italy. And similarly is also the food the food production in Malta, similar dynamics. The prices, as I said before in the introduction, I see movements here mapping, yes, but the effects are very much like muted. And a very intuitive finding here is if you focus on the energy prices in Malta, because of the subsidies, this transmission channel of a crucial sector in such shocks is offset by government subsidies. So it puts a shield on somehow on these cross-border effects. And this holds also for the energy, electricity and gas prices in Malta at the very bottom. I see a movement in Italy, but Malta is mainly muted. So here, government subsidies actually help to shield, to close this door of the cross-border transmission of the forces that are coming from Italy. Now, I also highlighted an overshooting effect of service prices for consumers. In a more detailed, of course, here a bit more on the surface level because of time, I'm not really able to go into detail, but what I find is that also the mapping here, so each component switches the component it appears once it crosses border. For example, unprocessed food in Italy reacts strongly, is very responsive to a temperature shock. In Malta, I don't observe any effect. This effect is in services. When I decompose, this effect makes a high contribution into the service IRF and a high contribution into the food production of Maltese variables. So what I see in the reaction of IP food here in this variable is actually highly determined by unprocessed food prices in Italy. So this cross-border reshuffling is also, I claim, an interesting finding on how these shocks transmit across borders to other economies via trade reshuffling. So far, so good. Let's switch the perspective and focus on droughts. Again, here I'm having an indicator variable of an extreme event. So this is binary, and it's a linear VAR. So much easier to follow in dimensions of interpretation. And what I see is mainly muted IRFs, both in consumer and in producer, or on the producer side. However, what is even stronger than in a summer temperature shock, than temperatures in the summer, is actually how the agricultural variables react, or the variables that are well connected to the agricultural sector, which is prices of food and unprocessed food prices in Italy especially. As for the cross-border transmission, again, much less of an effect of a drought compared to temperature shock. So all in all, what I've shown you is that temperature shocks affect some of the whole economy, and at the same time, producer and consumer prices are affected, whereas droughts mainly impact agriculture and food prices with limited cross-border transmission so far, as I see. And the effects of these shocks are not always the same in every season. As you saw in the case of temperature shocks, it's very crucial to control for the state, so for the season in which a shock occurs. If a shock occurs in the summer, it has a completely different effect when occurring in autumn or in winter, which is in line with previous works by Ciccarelli and co-authors. And another interesting and I think also intuitive finding is the case of government subsidies that basically close this door of transmission channel from the energy sector, which for climate shocks is a crucial one. Now, since this is work in progress, what I'm currently doing is extending the precipitation case into a seasonal setting, so we have a more comparable investigation in how the effects transmit across seasons. And at the same time, it's also important to take into account the sign of the shock. So far, I'm simulating an increase in temperature and a decrease in precipitation. However, you can just food for thought, an increase in temperature in summer where it's already hot might have a different effect than a decrease in summer temperatures, because summer is already hot. If I increase it by more, it should have less of an effect as if it is a negative shock to summer temperatures. And this is basically possible extensions that I'm currently working on. All in all, I thank you for your attention, and I would like to open the floor for questions if there is any. Yes, please.
So thank you very much. This is super interesting. And we're working also on weather data currently for forecasting food prices. And I think you could get more precision on the shock by using some, again, semi-microdata. Hidden in Eurostat, you have by region, by nuts region, the land that is used for agricultural production and the land that is used for energy production. So for energy production, it's only interesting for wind and solar. But for agriculture, so you could weigh the weather in Italy by how much of the land is used in Italy for producing agriculture. Have you thought about it?
This, of course, is an essential point. Thank you for pointing this out, because I skipped a lot. So what I actually did in order to have this time series Z that I was showing, basically I'm having on a NUTS2 level for each grid cell over Italy, I'm having an hourly observation. This is weighted by the gross value added of each NUTS2 region the grid cell falls in. And then over time, this enables me to have time varying weights because I have the GVA on a yearly basis. And this final shock series then is a weighted average of each NUTS2 region and grid cell compressed into one time series. So this is what, because yes, you lose a lot of information if you just throw it in there, and yes. Thank you, thank you. So if there is no other questions, I would like to ask Sarah to beat the heat.
Okay, so hello everybody. Thanks to you who stuck around till the very end. So, as Theo said, we're going to see a lot of parallels between our two works. And essentially, yes, we're going to try and beat the heat. Here we're focused on the predictive role of heat waves and droughts. And rather than focusing on two specific countries, we're going to be talking about all the regions in the EU. So, the usual disclaimer applies. Now, after all these days of cold wind and rain, why do we care about heat waves and droughts? So, as Chiara mentioned, the catalyst for this project was actually our namesake Beat the Heat hackathon competition way back in 2023. 2 years of on and off work. And now we're finally drafting the working paper, and we have an article coming out in a BIS bulletin. But of course, the larger motivation is the growing amount of literature, as Theo said, that says severe heat has cost, drought damages are projected to increase, and what is most relevant for the European Union is that there is a lot of regional disparities on the effects of these severe heat and drought. So our aim is to nowcast real GVA per capita for all the NUTS3 regions in the European Union. So we have approximately 1,200 regions for about a 20-year period. And we're going to focus on agriculture, so sector A, industry, B2E, and we're going to zero in also on manufacturing, sector C, using a combination of economic and climate data. So, to give you a bit of an idea of what's going on currently in the mainstream literature and where do we differ. So, a lot of the literature focuses on long-term impacts of temperature and precipitation, as there is still the perception that climate change is something of the next 30 years, but in reality, now we're talking more about next year, next 5 years, what are the impacts? So that's why we shift to a nowcasting perspective. Also, most of the analysis is very narrowly sector specific, and you tend to have a low resolution data, both in the terms of the spatial dimension, a lot of focus on countries or the euro area as a whole, for example, and low temporal resolution. So mostly yearly observations. On our end, then we have high frequency climate data, and we have the highly disaggregated spatial aspect. Also, methods remain largely linear for economic analysis, with some works like Theo, where you have the added non-linearities like the seasonal effects, whilst in our case, we say, okay, when you go and integrate the climate with the economic, there are a lot of non-linearities there, so why not try to experiment with some of the newer machine learning approaches that are inherently very non-linear, and we compare it to a benchmark linear regression. Also, as Theo said, a lot of the compounding effects are largely understudied at this stage, with most of the work being in the last 2-3 years. So we focus on these compounding effects as well. So, after all this, let's zoom in a bit on the climate data. So, we start from a set of temperature and precipitation-based features from the Copernicus Drought Observatory. It's a very rich climate data set. For heat waves, we have the Heat and Cold Waves Index, HCWI, from here on out. For droughts, on the other hand, it gets a bit more complicated. So we have 3 aspects of drought: the meteorological, which means is rain falling, yes or no. Here we have the standardized precipitation index over 3 different accumulation periods. Why? SPI1 is the more immediate effects, whereas the larger SPI12, here we go into what's happening at the groundwater level, how is it impacting reservoirs, things like this. We also have the hydrological drought. SPI12 is also related to this, but also we have the low flow index. This is especially relevant for mainland Europe, where you have stream flows and canals that are really impacted. And then we have the agricultural drought indicators. Here we have the soil moisture anomaly, SMA, and the fraction of absorbed photosynthetically active radiation. A bit of a mouthful, but essentially it's satellite data that tracks the health of vegetation. So all of these are restricted to focus on droughts and heat waves specifically, although if anyone is interested, they also give you the wetter and colder conditions. So, as I said, on top of all these indicators, we do a bit of engineering to get the compounding effects. On the temporal side, that is inbuilt into these indicators. That is one of the good side of it as well. So essentially, when we say about temporal compounding, for a heat wave to be declared, you already need 3 days of excessive heat. But of course, if a heat wave lasts even beyond those 3 days, a heat wave that lasts 1 week is different from a heat wave that lasts 2 weeks. Other than that, there's the geographic compounding, again, very similar to Theo. Here, for us, we essentially, my geographic compounding is a function of what is happening to my neighbors. So the geographic compounder is an average of what is happening to my neighboring regions. Other than that, we have the event-based compounders. So again, this is largely the understudied part in the literature. What happens if I am unlucky enough to experience a heat wave and a drought at the same time? And this occurs by, we measure this based on an indicator of our own design. It essentially takes the scaled heat waves and meteorological drought indicator at the different accumulation periods. We interact them, and also then we extract a singular indicator across the different accumulation periods of the meteorological drought indicator. Okay, so after bombarding you with all the climate data, how is this integrated into our nowcasting exercise? So, starting from the base functional forms, so our target is predicting the growth rate of real GVA per capita of our three sectoral aggregations. We have F-econ, which is our benchmark functional form. So essentially, we're predicting GVA based on its lag, the amount of employment, resources that are dedicated to the specific sector, the economic conditions at the country level, so GDP within the country. And then we have a set M, R, C, and N reflect the geographic conditions of the specific region. So these are the very region-specific elements. So M, for example, is if it's a mountainous region, R is how rural it is, C if it's coastal, and so on. Then FCLIM is the climate-augmented version. Here we have all our climate indicators that I went through, plus the geographic compounders. Theta, in both cases, is the hyperparameters that we tune and estimate. All the functional forms are estimated for 3 different models, the linear regression, our benchmark. And then we have our 2 machine learning approaches, the random forest and the extreme gradient boosting model. The trick of all this, what makes it hard, is the mixed frequency dynamic. The climate data is extremely granular in both time and space, but the economic is not. So although with the economic we have the advantage of the spatial granularity, we lack the time granularity. So our economic data is yearly. The climate data is even available hourly in some cases. So to deal with this, we have 3 approaches that we contrast again. One is a basic aggregations approach, our benchmark. So for climate data is highly disaggregated. Okay, we aggregate it back to yearly medians and standard deviations, similar to what is discussed in Ciccarelli. Then we have the more non-linear aspect of feature extraction techniques. One is not based on the target, you have PCA, whilst the other, the features are extracted based on my target. We have a beta polynomial Midas feature extraction technique. Why beta polynomial? Because the way the polynomial behaves tends to track well with how climate events occur. The fact that you have the build-up and then the tapering. So, after all this, what essentially are the results? We have 3 main takeaways. So essentially, if we focus on the first 3 columns, the linear regression side, we see that by adding climate features, we are not really gaining predictive ability, at least not to a statistically significant extent. However, in the machine learning dynamic, we do see that when adding climate features, especially for agriculture, we do gain predictive ability. We not only gain inferential insights in these cases, and also the nonlinearity not also helps with the integration of the climate data. When comparing to the linear regression counterpart, some of the machine learning models, even just the simple economic, are able to beat the linear regression. Another surprising insight is that although the feature extraction techniques have an added complexity, and if we really want to gain interpretability at the monthly level of the climate data, so if I want to simulate, for example, seasonal effects, yes, I could do it with the feature extraction technique. They have that advantage. But from this added complexity, I don't really gain predictability to a statistically significant extent. They do not leave me worse off, don't get me wrong, but the difference is not significant. So, parsimoniously, you could be better off in a predictive sense with the more simple approach. Okay, so after these results, machine learning models tend to be criticized as being a bit of a black box by some people. So we wanted to see what is under the hood. If the climate variables are giving me these results, why and does it make sense? So using a combination of SHAP values and factor loadings, we are able to see that the predictive contributions of the climate indicators do actually make sense and are in line with what we see in peer-reviewed papers. So for example, heat waves consistently impact the different sectors. That has an effect throughout. Drought, however, the type of the drought matters. I will not shock anyone by saying agricultural drought is important for agriculture, whilst the industrial sector, especially, so when we look at B2E, hydrological droughts matter, to the point where we're seeing, for example, the creation of new boats that can tackle the lowering of water levels in canals in mainland Europe, particularly in the Netherlands, for example. And with our SHAP values, given that we have the very disaggregated regions, we can pinpoint the specific regions that would be most impacted in scenario analysis. Then, when we look at geographic compounding, these contribute strongly towards predictions. Similar to what we saw with Theo, Italy does matter for Malta, and on a more disaggregated regional level, even within Italy itself, Rome is impacted by its neighbors, for example. Also, what we see very interesting between the regions, it is very evident, for example, with hydrological drought. So if we imagine a stream flow in Europe, and this crosses, for example, 5 different regions within Germany, if there is a drought that is impacting region A, and that causes a deviation to a different part of the stream, that means that there is costs and opportunities to the neighboring regions. And these kind of competitive dynamics between the regions of the same country have very interesting results for this kind of analysis, and are especially relevant for policy design. When we look then at event-based compounding, the results here are a bit interesting and difficult to interpret. When we look at everything on aggregate for our simple aggregations model, their predictive contributions are relatively weak. Whereas in the feature extraction techniques, where weights are assigned non-linearly between the different accumulation periods of SPI, our meteorological drought indicator, and these weights are assigned based on the sector that you're trying to predict, their predictive contribution rises. So this would be something to keep in mind if these models would be used for simulations. So also, we see that our climate variables tend to affect the predictions of regions that have below median real GVA per capita within the EU-wide distribution. This, again, is critical for policy design. So, the last part of all this, after having seen the predictive contributions of our climate features and checked with the literature whether these align or not, and on average they do, we see, okay, let me try and use this for a simulation. For the sake of being brief, here you have a really extreme scenario. So if we have an extreme heat wave and long-term drought happening at the same time with the magnitude of the 99th percentile that we observe in our distribution, what would happen? Here, in our simulation process, we pick the XGBoost with the yearly aggregations method for simplicity, and we have the no heat wave scenario versus our extreme case, and we have the differences. In the figure, you see the costs for agriculture on an aggregate level across time. This is not for a specific year or anything. So here something you see is that you have a bit of variation, but they're all negative. Some even go to the minus 10 percentage points level, which is quite considerable. Keep in mind, this is a very extreme scenario, of course, but also we see that given that this is the magnitude of an event that Northern Europe would not normally experience, here you have, for example, in Scandinavia, some of the more pronounced effects. Whilst this might not be the case of these things happening nowadays, and if you go into the realm of simulating 3 degrees Celsius of warming under the RCP scenarios, then these things would become more relevant. However, I must say, for the sake of conciseness, they're not presented here, but the industry and manufacturing sectors have way more muted responses than the up to 10 percentage points that we see here. But nevertheless, they are not zero. So that is everything from my end. Thank you very much. Any questions? Okay, everyone is tired? All right, thank you very much. Oh, sorry.
Maybe I
Yeah,
do if I can
go for it.
steal some of your time. I think one use of this, you mentioned policy analysis, but what kind of adaptation measures could be, say, do your results or can you get results pointing to the kind of adaptation measures that could help? For example, Netherlands is growing a lot of food indoors and controlled, but with a lot more energy cost, for example. So could you orient this?
It depends a lot on the data. So on the economic side, so if we were to see for example, spending on these kind of adaptation methods and climate relevant investment at the regional level, then yes, then all these things all of a sudden become possible. However, so for the sake of our analysis, we focused on the regional aspect. However, there's nothing stopping anyone from using similar techniques at the country level where this data then becomes very available. You lose some granularity in one space, but then you'll gain it in the time. So it depends on the research question, as we were saying earlier in the day, at the end of the day. Anything else? Go for it.
Sir, I have a comment or a question coming from someone who's not trained in these methods. I understand that you can use these methods for nowcasting, but how confident are we that we can use them for simulating, especially because you've said at one point, okay, I'm simulating something from the 99th percentile of what we have observed, but if we assume that going forward, temperatures will increase by 2%, can we say that in the sense that, okay, you've went into distribution and got a 99th percentile event and simulated it on your model, but your model have never seen a constant 2% increase of the average temperature. You know what I mean? It's completely using the old words. It's a reduced form. There's no structure. There's no theory. So even though there is nonlinearity embedded, but the nonlinearity is strained on what it has seen before.
Yes.
Can we say anything of that sort? That, okay, if a 1.5 degree Celsius happens all over Europe, this is what would happen to GVA. Is that, can we say that, or there are caveats attached to it?
So there are always caveats. So in fact, something that we're discussing deeply when it comes, now that we're into the drafting, is rather than this model used for simulations directly, something that we would encourage is that based on this essentially data-driven approach, you have an idea of which regions are going to be impacted with the within country heterogeneity, and then these things could be used within larger models that incorporate the climatological and the economy within a theory-based background. Because even the channel with which heat waves impact productivity are very important and can vary by country. So for example, for us within the Mediterranean, the effect is generally talked about labor productivity. If it's over 35 degrees, I don't necessarily feel like working, for example. Or if there's no AC at work, my productivity decreases. Whereas in Northern Europe, it's completely different. Whereas here, for example, case in point in Malta, we're not talking about canal flows, you know? So it's, the 99th percentile in itself is extreme, but if I were to pick a lower threshold, then I would be more confident with saying this to be used directly. For something as extreme as the 99th, then incorporation into a larger model would be the way to go. Anything else? All right, thank you.
Thank you, Sarah and Theon. I now invite Deputy Governor Alexander De Marco for his speech, which will eventually close today's event.
Dear guests and colleagues, good afternoon. So when the organizers informed me that Dr. Chiara Obstat had accepted to participate in this workshop, I was very much thrilled, and they don't know why. But the reason is because she brought back memories of work that I had done some 20 years ago or so, when we had to estimate the equilibrium exchange rate of the Maltese lira against the euro. At that time, Malta had just become a member of the EU, and the policymaker was already thinking of the next step to adopt the euro. And I had found very good use of her 2004 paper together with Maceo Fernandez and Bernd Schnatz from the ECB. So that brought a lot of memories. So basically, as we reach the end of this year's annual research workshop, I would like to, first of all, thank all our brilliant presenters and researchers at the bank. It was very cutting-edge work that they have been doing, and of course our keynote speaker as well, and all those who took part in today's discussion. It's been a day full of rich ideas, methods, and very much forward-looking analysis. This year's Research Bulletin and today's presentations have showcased the diversity and depth of our research. We saw how microdata and machine learning can improve our real-time understanding of inflation dynamics, how detailed tax simulations shed light on distributional issues, and how new models can help us better interpret monetary policy, supply-side developments, and cross-border climate spillovers. Together, they strengthen the analytical foundations on which policy is built. Dr. Obstat's keynote speech captured the central theme of today's workshop, the power of microdata to answer macro questions. By grounding our analysis in observed behavior at the household, firm, and sectoral levels, we gain a clearer view of how economic shocks propagate and how agents react and how policy can respond effectively. As she highlighted, the ongoing transition towards increasingly granular data sets creates both opportunities but also a lot of challenges, underscoring the importance of cooperation and the development of a true community of practice, which is especially valuable for small institutions like ours with very limited resources. Looking ahead, our research agenda will continue to evolve along several key lines. Firstly, we continue with our endeavors to improve our forecasting and nowcasting performance, not only through innovative data sources and modeling techniques, but also by deepening our understanding of data revisions, which we have an experience a bit of this, and their impact on forecast accuracy. Reliable short-term assessments remain a cornerstone of effective policy, and improving it is a continuing priority. Secondly, we shall be devoting greater attention to long-term drivers of the Maltese economy, including demographic trends, labor market participation, and productivity growth. These structural factors shape our medium to long-term outlook and are essential for building resilient and sustainable economic policy frameworks. Third, we will enhance the granularity of our models and data, incorporating further sectoral disaggregation and developing new input-output and value chain linkages. A more detailed mapping of economic interconnections will allow us to capture how shocks travel across sectors, prices, and production networks. An increasingly important dimension, I would say, especially for a small open economy like Malta. And finally, we will continue refining our frameworks for spillover analysis and scenario building, which has become an increasingly important input in monetary policy, including in the euro area, in times of high uncertainty, linking domestic developments to global and regional trends, and strengthening our capacity to assess cross-border effects, whether financial, real, or climate-related. These directions all point to one goal: improving the quality, timeliness, and relevance of the analytical work that underpins policy decisions. In closing this research workshop, I thank our researchers for their dedication, the many colleagues who contributed to the bulletin and to today's workshop, and our partners across the Eurosystem and academia for their ongoing collaboration. The discussions we have shared today are a reminder that research is not a solitary exercise, but a collective effort to understand increasing complexities in economies and to support sound, evidence-based policy decisions. Thank you all for being part of that effort, and I wish you all an enjoyable afternoon. Thank you.